Hi, listeners. This is the 80,000 Hours podcast, where we have unusually in-depth conversations about the world's most pressing problems, what you can do to solve them, and whether it's a good idea to spend hours coming up with a joke about information security for this intro. I'm Rob Wiblin, head of research at 80,000 Hours. I love being able to find people who haven't done many interviews and giving them some of the exposure that their work truly deserves. And Nova DasSarma is a sterling example of that kind of episode. Computer and information security are super interesting in themselves, and they may turn out to be critical to the safe development and deployment of AI systems that have very broad capabilities. So I had a lot of pressing questions to bring to Nova. We also talked about how important it is to have access to enormous computing power, how you set up an AI computation center most efficiently, and whether making computers secure is a lost cause with current technology. Oh, and we also geek out about what stuff it's actually worth everyone like you and me doing to ensure that we don't get hacked in a way that does us a lot of damage. At the end of the episode, I'm going to highlight quite a few of my favorite other podcasts, including a few that are pretty similar to this very show. So stick around for the outro if you're keen to hear that. All right, without further ado, I bring you Nova DasSarma. Today, I'm speaking with Nova DasSarma. Nova studied information systems at the University of Maryland, Baltimore County, before going on to be a system administrator for a range of university research teams, and then a data engineer at various tech companies. She is now the lead systems architect at Anthropic, which, among other things, means she's responsible for information and computer security there, as well as engineering their ever more elaborate computer systems to get as much useful computation out of them as is practical. Anthropic, you may know, is an AI company that aims to build prototypes of reliable and steerable AI systems. And we last discussed Anthropic in episode 107, Chris Olah, on what the hell is going on inside neural networks. Nova is also a co-founder of the non-profit Hofvarpnir Studios, which aims to build a GPU cluster that can be used by academic researchers, aiming to improve the safety of cutting-edge AI systems. Thanks so much for coming on the podcast, Nova.
Hi, Rob. Thanks for having me on. I'm excited to talk about why information security and infrastructure matters for AI safety.
Yeah, exactly. Yeah, I'm hoping we'll get to chat about why there is this kind of important interaction between information security and AI development, as well as how you got into this somewhat unusual line of work. But first, as always, what are you working on at the moment and why do you think it's important?
Sure. Yeah. So at Anthropic, I'm working on securing compute power to run the experiments for lots of large language model kind of experiments. Turns out that a lot of ML is like pretty simple experimental concepts, but they require pretty ridiculous engineering efforts to actually run those experiments. And so a lot of my job is making those feats of engineering possible. And at Hofvarpnir, I'm writing some software for helping academics containerize their workflows mostly these days. And it turns out that that's pretty important for being able to scale and secure a lot of the software that you're working on. We're also building out that cluster that you talked about.
Yeah. What is containerizing a workflow? I don't know what any of that means.
Sure. Yeah. So when you're writing software, oftentimes you'll have some program that talks to an operating system and it runs on a particular stack of hardware plus software. Containerizing a workflow is talking about taking that software that you've written and then talking about the dependencies that it needs and the software stack that it needs and bundling that into one big image that you can then run on any kind of hardware. So it's sort of system agnostic. You also get some security benefits from doing this. Obviously, most containers don't have this, but there are definitely ways to make your containerized workflow give you security benefits as well.
Nice. Okay. And the first thing you said was that thinking up experiments that you want to do relating to AI or machine learning is somewhat straightforward. And maybe the surprisingly harder part of it is engineering, I guess, the hardware that allows you to actually do those experiments in a timely manner. Am I understanding what you said, right?
I think that's the way that I would think about it. I think that there's a lot of really interesting ideas and a lot of low-hanging fruit in AI right now that people just don't have the infrastructure to be able to run the experiments to do things. So, for example, if you want to scale a large language model, you're going to need hundreds of millions of dollars of compute, and you'll need to be able to organize that in such a way that you use it efficiently. And those problems are more traditional software engineering problems, but I think a lot of the talent there isn't in the AI safety space. And so it becomes a bottleneck, I think.
That's interesting. I guess it sounds a little bit like the very expensive science projects, like the people working on fusion and the people working on colliding atoms and the people who want to like look at information from deep space from billions of years ago using these incredibly expensive satellites. You've kind of got this like hardware bottleneck where lots of people have ideas for what they'd like to look at, but only so many people can do so many things.
Yeah, for sure. I think it definitely compares to some of these really large science projects. And actually, Anthropic has a lot of physicists there, so I think that's a very appealing comparison for them.
Yeah. I guess we've talked about this issue of hardware being a bottleneck on the show before. I guess that's been the case from memory for like 6 years or something like that, or that's been increasingly kind of the case for maybe the last decade or longer. But I mean, I'm old enough to even remember a time when people would talk about, random academics doing interesting work on AI, and then they could do it on what I imagine is a much more limited budget than what's required today.
For sure. I think that one of the things that we got out of the GPT models is that if you scale a large language model, you can get some pretty interesting phase changes in the results, those hockey stick graphs that make everybody nervous. And so those are things that only show up at scale. And academics just don't have the access to resources. And I think that's one of the things that Shauna and I want to fix with Hofvarpnir. But yeah, it's really unfortunate that academic computing hasn't really kept up with industry. And that's why I think a lot of those discoveries come out of, Baidu or Microsoft or OpenAI, Anthropic, places that have a whole bunch of money to run a very large compute cluster.
Yeah. Okay. Yeah, we'll come back to Hofvarpnir and compute and issues like that later on in the conversation. But the thing I was most psyched to talk with you about is computer and information security and kind of the interactions that has with development of cutting edge ML models. For those in the audience who are kind of not familiar with this topic, why is Anthropic working on computer security as a kind of important organizational priority?
For sure. So for one thing, when you have a large language model, you're oftentimes going to train it on a large number of GPUs for a long time. And this produces this asset, which is these weights for the language model. And this is an incredibly expensive asset for the size of it. You can have something that's a couple of gigabytes that costs millions to produce. And so that's a very appealing target for a lot of bad actors. So security is pretty important on that front. On the other side of things, and more directly safety related, a lot of research in AI can be dual use. And so protecting your code, protecting your model weights, and that sort of thing is ever increasingly important as you have more powerful models.
So one important priority is you're developing these models. They've got these weights that were very costly to figure out what numbers they ought to be. And you want to keep those inside the firm rather than just have whatever ne'er-do-well come in and swipe them from you. Are there any other kind of key computer security challenges that Anthropic needs to solve over coming years and decades?
For sure. I think that we can talk about security as also something where you have a model that's we hope is steerable and we hope is reliable, that sort of thing. You can talk about that as also a security risk. So if your model is able to do things like cough up social security numbers or cough up passwords and API keys, that's also a computer security issue that we care about quite a bit.
What about the idea of you want to run a model, but you're not sure quite how safe it is, so you want to kind of constrain what resources it has access to? I guess this is some variation on the idea of boxing an artificial intelligence. Is that also a computer security issue, or is that kind of under a different header?
Yeah, very definitely. And I think it's one of the things that I've been worried about quite a bit. So as we're recording this, I think it's March 31st. Yesterday, Salesforce released a 20 billion parameter code model. And as part of their training loop, they use something called the human eval environment. And that's an environment for looking at executions of code. And I think one of my concerns has been that this is sort of an industry standard, but there are some pretty subpar security practices with sandboxing the executions of code in that environment. And honestly, I think it's one of the places where Anthropic might be interested in giving back in terms of preventing or making it easier for actors to sandbox code executions, because you really don't want your nascent AI model running arbitrary code with access to the network.
Right. Yeah, that sounds right. Let's maybe talk first about this issue of data exfiltration, because it seems like one that is present at the moment and potentially not a simple one to solve. I guess, so you train these models, costs a whole lot of money, takes a whole lot of compute. Potentially, I suppose these models could have capabilities that you don't want to be immediately widely applied. But if the model is, as you say, only various gigabytes of data, it seems like it's going to be very hard to stop someone from stealing that data if they're really, really committed to it. Yeah, what in practice can be done?
Sure. I think that a lot of security is about detection of bad actors within your organization and with access to your systems. So one of the things you can do is you can limit who has direct access to these model weights. You can look for suspicious patterns. So for example, if you're operating and all of your employees are in San Francisco and you see somebody trying to access files from Omaha, Nebraska, you might want to have software that raises an alert for some kind of intrusion detection or exfiltration there. So that's one of the things that's like very much an observability problem in security.
Yeah, okay. I suppose maybe I've jumped the gun on that. Perhaps first we should talk about kind of what sort of actors you're actually worried about, because I imagine different actors are going to have quite different capabilities or present a different style of threat.
For sure. And I think this is a really tough topic in security, because the more you're trying to defend against, the less usability you have within your system and the less you're able to do things like iterate fast, to be able to collaborate with other people and that sort of thing. And there has to be some measure of trust in the system to do any of these things. The most secure system is the one that you never turn on, is something we like to say. But yeah, in terms of actors who might interact with these systems in ways that we would consider negative, I think that corporate espionage is something that is a big topic. And obviously there's some amount of, foreign intelligence services and things like that, especially as AI becomes more capable, that might be concerned about things being produced within labs like OpenAI or Anthropic.
I see. Okay. So states would be one grouping.
Yeah, I think states would be a grouping. You can also talk about individual actors and motivated people within your organization. And that's one of the reasons why I think keeping organizations small, making sure that you've got good alignment, doing things like background checks can be pretty important in limiting your attack surface, especially for those individual actors.
Yeah, that makes a lot of sense. Is there another category?
Between individual, corporate and state?
Yeah, well, I guess I thought you might just talk about criminals who want to make money, perhaps steal your data and then sell it to whoever, or like use it personally.
Yeah, I actually, in my head, I sort of group this in this corporate zone because it's a large number of individuals who are sort of oftentimes very profit motivated to retrieve these sorts of things. So we've definitely seen that with the group that's been breaking into Microsoft and Okta and various other like high profile hacks recently. That's been something that's been in the news. So that's certainly something that we're on the lookout for.
Yeah, I guess one sort of misuse that probably you don't have to worry that much about is kind of another respectable company in the United States like Microsoft stealing your model and then trying to apply it. Because I imagine that the legal liability or the intellectual property issues there mean that that's just not interesting to them. They'd rather deal with you and try to buy the service or catch up by hiring people or something like that. So we're mostly talking about actors that are kind of other than those ones. For
sure. Yeah, I think that worrying about individual actors and worrying about cyber criminals, so to speak, and state actors are sort of your three things that you really care about. Though the difference can be not that much depending on what country you're operating in.
Right, yeah. So I guess there are some countries that don't fully respect other countries' intellectual property. And I suppose you can also see some countries have gotten more respectful of IP over time. Some countries have gotten less respectful of American IP over time. It kind of depends on broader geopolitical factors. I guess we kind of started talking about this, but is there a clear kind of breakdown of the different misuse cases? I suppose there's one where, say, a state takes the IP and then uses it for, potentially hostile state-based purposes. There's another company just deploying something in order to make money. And then I guess there's the other, just like the IP or the model being spread quite widely and deployed in a whole lot of situations where you might not endorse it before you think perhaps it's ready for prime time. Are those kind of the main categories?
I'd say that those are the main categories. I would also throw ransomware on there. We saw something with oil pipelines on the East Coast recently, where it turns out that motivated actors can break into your system, encrypt all your data, and say, well, give us some money or we won't give it back to you.
I see.
And that's quite hard to defend against in some ways.
Yeah. Okay, so we've got those various different categories. I guess different people have quite different visions of how artificial intelligence is going to advance and how it will end up influencing society. I guess on one extreme, you have the folks who think it's going to, at some point, advance incredibly quickly and, take off within days or weeks at the point once a machine learning model is capable of self-improving itself incredibly quickly. On the other hand, you have folks who expect the deployment to be quite gradual, and maybe some capabilities to come quite early, but others to take a very long time in order to reach fruition. how important is it to have kind of a picture in your mind of how artificial intelligence is going to affect the world in the 21st century in order to figure out what your priorities should be from a computer or information security point of view?
Yeah, I think from a theory of change perspective, it's pretty important to have a good model of what an AI takeoff could look like, especially because if you think that the difference between a subcritical and a supercritical model is very limited, then you might want to work harder on keeping some of those models where you don't think that they'll take off, but you don't really know what would happen if you added another billion parameters to them, under wraps more. That being said, I think that all actors should basically be trying as hard as possible to defend against these sorts of attacks, whether they have a hard or soft takeoff model for issues with AI systems. And of course, this is sort of beyond my area of expertise to some extent. My role is more on the infrastructure end.
The implementation, rather than the big picture theorizing. I mean, so my perception as someone who takes a slight amateur interest in information security issues is that the state of the art is very bad, and that we do not really have reliable ways of stopping people from, or like stopping a really advanced, well-funded adversary from stealing data if this is something that they're willing to invest a lot of human capital in. Is that kind of right?
I think that's kind of right. I've got a story here if you want to hear it.
Yeah, go for it.
Around this. A state that will not be named had an attack that was in the news recently that was a zero-click vulnerability on iMessage. And so a zero-click vulnerability being one where the user doesn't have to take any actions for them to be compromised. And this had to do with something called the JBig2 compression algorithm, which you might have heard about because back in the day, Xerox used to use this for copiers, and it's a compression algorithm, which means that you can copy things faster. But it turns out that if you turn the compression up too high, it turns zeros to nines and vice versa, which is quite bad for numerics. That being said, JBig2 was also the culprit in this case, where their compression algorithm is dynamic, which means that you can specify patterns on the fly. And it turns out that if you construct a file that has the JBig2 codec in it, then you can construct gates out of this, so logical gates, which means that in theory it's Turing complete. And in practice it was Turing complete. And so to deliver this vulnerability, they produced a computer within the JBig2 decompression algorithm to deliver the payload to these phones. And that's the sort of thing where you could theoretically have defended against this, but the way that you defended against this was least access, so not being able to access anything on your phones, or not having phones. Both of these things are really quite difficult to implement in an organization above a certain size that doesn't have a very, very strong security mindset.
Security culture.
Yeah.
Yeah, right.
So that's like on the state access side. That being said, the thing that works the most is always going to be a social attack. So something where you meet someone at a party and they seem nice and they become your friend, and then you let them into your building when you maybe shouldn't have done that, and they plug a USB into your system and you're done. We talk about physical access being the end of the line in security oftentimes. So that being said, yes.
Right. Okay. So there's one thing of like a very well-endowed actor can develop 0 days. Or we basically live in a world where states are able to figure out completely new ways of breaking into computers, into phones, that people can't protect against because no one else is aware of them, and potentially they can require no action whatsoever. I suppose even more accessible to actors who have less money is this kind of social engineering attacks where they'll convince someone to give them access, and this doesn't require quite the same level of technical chops. But nonetheless, basically, it's extremely hard to secure a system to be very confident that it's not vulnerable to one or the other of these approaches.
For sure. And I mean, on the social engineering side, you don't need the folks who have the most access in your organization to be compromised by social engineering attacks. Oftentimes, those are the folks who are least vulnerable to that. All you need to do is have somebody who is, on operations, or somebody who is maybe even the physical security person for the building who connects to your corporate Wi-Fi, be compromised, and then they can be the threat vector into your organization. Yeah.
So given that we live in that kind of world, should we just not be training models that we don't want to leak, or where it would be disastrous if they leaked? It seems like we just don't live in a world that's safe for that kind of ML model yet.
For sure. And I think that's definitely something that a lot of labs would definitely have on their minds. I think that it being difficult to secure models is one of the reasons why we wouldn't want to train such models. I think that models with a lot of capabilities are oftentimes very alluring for people to build anyways, though. And so my perspective on this is that it's important for me and people who I work with to develop tools to defend things anyways. Because if you can detect, if you can disrupt that sort of attack while it's happening, if you can notice it's happening, then you've got a better chance of keeping things contained longer.
Yeah. I guess, yeah, I remember a couple of years ago, folks were really worried that the GPT-2 language model and then the GPT-3 language model might, like, if people had broader access to them, or they could reproduce that kind of result, that those models could then be used for crime or just some kind of negative purpose that we haven't yet thought of. I suppose, actually, yeah, I remember people thought that perhaps that'd be used to simulate actors on social media and just create so much noise on social media and make it impossible to tell who was a real person and who was not. I guess, for that matter, a lot of people, including me, kind of predicted that during the Russian invasion of Ukraine, we'd see a lot of cyber attacks. I guess competition between the US and Russia, as well as, I suppose, Russia using cyber attacks in order to deactivate infrastructure or personnel within Ukraine. But as far as I know, we kind of haven't seen very much of that. Is this little reassuring that, although in any specific case, there's like a lot of potential for information to leak, information to be misused, in practice, just lots of things that could happen don't happen?
Well, I hate to disagree here.
Okay, yeah, go for it.
Unfortunately, we actually have seen quite a few things that look like this. So not on the AI side, but during the Russian invasion of Ukraine ongoing, one of the most successful Russian efforts was to disrupt communications out of Kiev. And that was definitely something that involved a cyber attack on Ukraine. We've also seen Ukraine, punch back, have a call to action for their homegrown hackers to take on the Russian state there. And we've seen that sort of thing. In the software ecosystem, we've seen some serious disruptions from individual actors doing things like there's an NPM package, so NPM being the JavaScript package repository, where somebody pushed a malicious code update that checked whether the code was running on a Russian or a Belarusian computer. And if it was, then it deleted everything on the hard drive. And this was a project that was included by many, many other projects. And it turns out that was like quite damaging. There's a thread which I have no way of verifying on their GitHub from somebody claiming to be an NGO operating for whistleblowers out of Belarus, claiming that this actually ended up deleting a whole bunch of data for them. So certainly we have at least some people claiming that this was something damaging. We've also seen on social media evidence of manipulated profiles and things like that, where images were generated not by, GPT-2, GPT-3, but by things like Clip. And you can see the telltale sort of signs of an AI-generated image where there are things like, an earring is only on one side or something like that. Various kinds of oddities around the corners of the eyes and hairline and things like that, where we see some of these things. And I think, honestly, there are more of these than we know, because if they're successful, then they're undetected. You have to be doing it quite badly to be detected there.
Yeah.
Sorry, one other thing, though. People are very, very good at doing these sorts of attacks on their own, and humans are quite cheap compared to somebody who can, play GPT-3 like a piano. It's easier to just hire 1,000 very low-paid workers and just hire them to do this and have them do this all the time. And it's way easier to train them than it is to train a ML model. So I think that's part of the reason. And I think as capabilities increase of these large language models, the potential for abuse increases because their capabilities outstrip that very cheap labor.
Okay. Yeah, that makes a lot of sense. My perception is that the AI and ML field has in the past had this kind of academic culture of sharing results so that other people can replicate them, like publishing papers basically explaining everything that you're doing. I suppose if it's important to keep secrets and it's important to keep models under wraps, I guess we're expecting and maybe hoping that that kind of culture of just universally sharing models is going to come to an end, or at least be modified in important ways. Is that right?
I think that's something that we've seen already. I think we've seen things like, for example, the GPT-3 model was released as an API rather than as access to code and weights, that sort of thing. So I think we're already sort of starting to see signs of those things. That being said, I think that academics have a culture that is going to be quite difficult to change, even in the face of something like this.
Right. I guess you might get this cultural change just because most of the cutting edge work is going on within companies and these large AI specialist organizations rather than among academics because they don't have access to the compute, for better or worse.
Yeah, I think that's one of those things where culture is done by replacement rather than convincing people.
Yeah.
And certainly that compute barrier is one of those things that has made this easier, and having a limited number of actors, that sort of thing.
Yeah. Are there any historical case studies of information leaks in ML? Are there any cases where, an ML model has been stolen in the past?
That's a great question. I don't think I can think of one offhand, actually. If they have been stolen, then it's one of those things where they've kept hush-hush about it.
Okay, yeah. I suppose in the past, the incentive has been less because it's often been possible to replicate the work one way or another.
Yeah, I think it's definitely something where we think that the data is the thing that's valuable and the data is something that's open source. So, yeah, I think it's not something I've seen.
Yeah. An audience member wrote in with a question wanting to know your take on this hack of Nvidia that I understand happened in February. For listeners who don't know, I think there was a group as yet unidentified that stole a couple of gigabytes worth of data from this semiconductor manufacturer called Nvidia. I think one of the largest semiconductor manufacturers in the world. I think they have some of the leading chip designs for ML among other applications. And basically, I think the amount of data was not that large. We're talking gigabytes, but it probably cost billions of dollars to produce the data that was contained in there, or at least potentially it could be worth billions of dollars to other actors if they could get access to it and use those results to design their own chips. Yeah, do you have any thoughts on that event?
Well, first of all, Rob, I'd probably like to say that it's really unfortunate that happened from a safety perspective, because a lot of the chip design and things like that inside of Nvidia relies on some secret sauce that only a few engineers inside there know. And so having that information be more accessible is probably not bad. That being said, a lot of the really hard work inside of things like making a GPU or other AI accelerator card is going to be on the hardware and the execution side more than the ideas. You can certainly take one of NVIDIA's A100 cards and take some, hydrofluoric acid and decap the chips and take a microscope and take a look at the circuit that's inside there. And that's almost certainly something that other companies have already done.
Yeah.
So I think that some of the IP loss is unfortunate, but not as bad as it could be. Was it preventable, though? I think probably not. I think that NVIDIA is a large enough organization that this is the sort of thing that we're lucky it didn't happen earlier. Or we actually have no way it's possible of knowing. It's possible that it did happen earlier and we just don't know about it.
Yeah, it's interesting. I actually own a bunch of Nvidia stock, and I've owned it on someone who will go unnamed recommendation for quite some time. And I think since I bought it, it's more than 10x. Anyway, this prompted me to take a look at when someone told me about this hack. I took a look at the share price, and it hadn't moved at all. I think when the announcement was made.
I'm not surprised. It's definitely one of those things where the information is going to maybe level the field for somebody making an NPU or something like that. But the real limiter on doing these is having really talented people who can run fabs, can take these designs and convert them into actual chips, that sort of thing. I imagine that whatever information they have, it's going to be quite difficult to apply it.
Yeah, that makes sense. I suppose it might help people catch up to some previous stage perhaps, or gain insights here and there, learn stuff, but to actually replicate what Nvidia is doing would based on these files would be tremendously difficult. You probably have to hire away a whole bunch of people from Nvidia and get them to help you to do it.
Yeah, honestly, if you're trying to beat Nvidia, that's the easiest way to do it. But I mean, if you look at, for example, AMD has a chip that's pretty comparable to the A100 series. It's the MI200 or MI250 series. And one of the reasons that isn't as used in things like machine learning is that the software stack just isn't there. And I think if you were an actor who bought this NVIDIA, stolen IP, hoping to create your own chips and things like that, it's possible that you could do something that would be compatible with the NVIDIA APIs. It's possible that you could do something that's going to be comparable in performance. But by the time that you get there, they will have moved on. There will be another die shrink unless you have ongoing access to this information and the hottest team of silicon engineers on the planet. I think it's not going to be very useful.
Okay, yeah, that's interesting. Coming back to the preventability, I guess you're just saying, given the current state of information security, that in order to keep this information secret, they would have to bury it so deeply that it would interfere with their operations more than it would even be worth in terms of protecting the information. And so basically we should just expect, like, if a piece of information is this valuable and this obvious, we should often expect it to be stolen one way or another.
I think that's a good expectation to have. It might not be what actually happens. I wouldn't give, greater than 50% on a 1-year timeline of, like, for example, Hofvarpnir's CTL command being stolen. But it's a good mindset to have. It makes you think more carefully about what sorts of capabilities you're developing and things like that. Because if you assume that a bad actor is going to use it, then you're going to be in a better state if they do actually end up using it.
Yeah, you mentioned in response to the first question in this section that you can kind of think of AI alignment and AI safety as kind of an information security or computer security problem. Could you flesh out that perspective a little bit more?
Sure. So when we talk about something like an AI system that can do something like, for example, OpenAI Codex or Salesforce's 20 billion parameter model that can write some code, you worry that the code that it is putting out into the world is something that will allow it to have capabilities that you might not want it to have, allowing it to put its subagents into the world, that sort of thing. And this is quite similar in some ways to trying to have a boundary of preventing execution by other actors inside of your organization. Yeah. So I think that there's a symmetry there.
Yeah.
And lessons to be learned from traditional information security.
Yeah, so what implications does that have for what a place like Anthropic ought to do? I suppose it means maybe you want to just hire a lot more InfoSec people because they can be potentially involved in the trading of ML models or thinking about how ML models can be designed better, as well as like securing the networks themselves.
Oh, absolutely. I think that if you're out there doing security and you would like to work on a very interesting problem, Anthropic almost certainly has a role for you.
Yeah.
That being said, yeah, we've done a lot of work on looking at things like human eval and trying to figure out ways to do more clever sandboxing, find ways of limiting the capabilities of something like running the Salesforce model, that sort of thing.
Yeah, tell me more about the Salesforce model. I didn't quite understand what it is that model does.
Sure, yeah. So Salesforce just released yesterday a 20 billion parameter model, which they claim does better on evaluations than OpenAI Codex, which is a 12 billion.
What's it evaluating?
It's evaluating its success at converting human-readable descriptions of problems to code that can answer those problems.
Okay. So it's converting. So someone writes a description of something that they would like a computer to do, and then it codes that up and tells whether it's succeeded at doing that?
Yes, exactly. Yeah. And you can imagine why a place like Salesforce would want this, given that their business model is absolutely trying to take business rules and convert them into computer systems. So it's pretty exciting to hear that they're thinking about ML models here, even if it is somewhat alarming.
Yeah, okay. Yeah, why is it alarming?
I think it's alarming because I think that code models in the wild are generally something that increase the ability of people to deploy code. And oftentimes, I think we already have a problem with a lot of people deploying code without thinking about security implications of it. And that's even within a very, selected group of people who have, done a bunch of training.
Have gone through computer science degrees and, yeah.
Maybe done a computer science degree, certainly hung out with people who spent their time in their youth breaking into systems and that sort of thing. I think that there are a lot of folks on the business side of things who might not be thinking quite as carefully about what that code looks like. In my last job, I worked on a no-code system for financial products. Certainly one of the things that I learned from working with a bunch of banks is that a lot of the folks there are more concerned about bottom line than they are about information security beyond compliance.
Yeah.
So it's certainly something that I'm concerned about.
Yeah, this situation reminds me almost suspiciously exactly of the Sorcerer's Apprentice thing from Fantasia, where I guess you're saying there's all of these junior folks who will suddenly have the ability to automate a whole bunch of stuff, but they might not appreciate what they're getting themselves in for if they just start coding things up using this evaluation model from day to day, yeah?
Yeah, absolutely. Yeah, I saw a post the other day which was talking about test-driven development where you produce like a set of specifications, right, for what your software should be able to do and what it shouldn't be able to do. And they've got this function for randomness, and it returns 8 and it says that this was randomly selected at the time of writing this code. And it's one of those things where understanding what's actually wanted is a very, very difficult problem, even for programmers.
For a 20 billion parameter model.
or even for, especially for a 20 billion parameter model. Yes.
Yeah. Okay, so to what degree could we solve any of these information security issues by like putting information that we don't want to get out there on ice somehow, like putting things in cold storage, except for like the exceptional cases where occasionally you want to access them for some practical reason?
I highly recommend it. Yeah. I think that certainly limiting the amount of information you have that is eligible to be exploited and that is easily accessible is a great way to limit your footprint. So things like if you've got a model that you trained and you have a whole bunch of checkpoints and you're storing them on some online system, consider whether you need to do that. Consider whether you could instead encrypt those and put them on something like Amazon Glacier or Google Snowball or something like that, where you've got a cold storage, it's going to take several hours to restore it, and you can absolutely set an alarm if somebody tries to restore that information without letting you know.
Yeah. Interesting. What are some of the most secure networks that exist today, or most secure like computer systems that exist?
Well, I think that my TI-84 Plus calculator is pretty secure because it can't connect. I think it's hard for me to comment really on the security of other organizations. I think that everyone's trying very, very hard to produce systems that are secure and reliable because that's very much important for their bottom line.
Yeah. One system on a bunch of computers that I've heard of that is very focused on security, I think, is maintaining the like encryption keys that underpin the domain name server system that I guess that allows us to find websites on the internet. Do you understand how that system works at all?
Sure, yeah. So DNS is a system where you've got a hierarchical name lookup. You've got some servers that understand the concept of .org or .com, and we call these like the root domain servers. And then there are other servers that inherit from these, essentially, that you can then look up things like google.com or anthropic.com or something like that, because obviously these servers are getting many, many queries a second, and trying to avoid that is like pretty important. It's something where if you had a sufficiently motivated actor who was able to compromise one of these root servers, you might be able to redirect traffic for a large portion of the internet. So the security measures taken around that are pretty high compared to many other parts. Is that what you're talking about?
Yeah, that's exactly what I'm talking about. And I guess, so I've seen a slightly clickbaity video that tried to describe what some of the precautions that they took. I think for like, is it like the original signature keys that verify that it's a legitimate server or something like that they're trying to keep secret?
Okay, so I think this has to do more with... So there's another system called HTTPS. So if you look in your browser's URL bar, you'll see like an HTTP or an FTP or an HTTPS. Oftentimes it's got a lock beside it. And the way that you verify that this encryption is secure is that your computer has a stack of certificates, and it looks up on that chain what those certificates were authorized by and that sort of thing. And so, yeah, the root certificates that were issued by certificate authorities are very much something where you don't want that compromised. And so having a multi-part step where you've got cross signatures, I think, is the main thing that really secures these, where one certificate authority is guaranteed by several other certificate authorities. So you've got this sort of shadowy cabal that's managing encryption for the internet.
I see. Okay, so on this video I saw, it kind of said that they had this thing on cold storage, but like that's not enough. So they put it in, a Faraday cage so no one can use wireless stuff to try to break into it. And they've got like obviously like physical security, so people with guns, and I think there's a vault underground. And then to get into it, you have to get like 6 out of 9 people who have keys to open it up, and then each of them knows only part of the password. So it's like I suppose this is an unusual case because it's something that you can kind of keep on cold storage. You don't necessarily have to use it all that often. You only have to access it periodically.
Yeah, it's definitely one of those things which is where it's very valuable information that's very small. This would be, I think, more difficult with a lot of other sorts of assets that you have in a situation like this, though.
Yeah. I guess it's a slightly hopeful example in that to my knowledge, these keys have never successfully been stolen. Or maybe I just haven't heard
Not
about it.
Not as far as we know.
Okay, not as far as we know. Okay. So at least if you don't need to use data, then maybe you can secure it by sticking it in a very deep bank vault and having people with guns protecting it.
Yes, I think oftentimes the answer is you have people with guns outside. When you look at, for example, the US military and you look at software that's developed for their secure systems, you have something that's called a SCIF. It is, I think it's a secure computing information facility, if I remember correctly, where you do have a Faraday cage built into the building and you can't bring any outside devices in, and you do have people with guns outside. And so every day when you go into work, you have your ID badge, it's verified, you go through metal detector, and you never take any of your code outside. And that's definitely something that seems like the way that some of these systems are going. It is, of course, very, very inconvenient to do things like this. So if you're actually trying to get developers to work in here, you need to have copies of things like documentation and package repositories and various other kinds of infrastructure that we sort of take for granted as developers. You need to replicate all of those things, keep them inside the building, and ensure that when you created them, you didn't also create a vulnerability in there, because these systems eventually will interact with the outside world. That's part of what you're doing there. So if you've got a sufficiently motivated actor, it's possible that they got deep cover something into that building.
So this is kind of if you're designing the software that runs a tank or some incredibly sensitive military thing. I guess the systems that run nuclear, just like strategic nuclear systems, would be designed in this kind of extremely secure facility.
I think nuclear system sounds like something that would be there. I imagine that various three-letter organizations have software that's developed inside of SCIFs as well.
Yeah. Okay, and I suppose that's very difficult to do, and I guess it's not the kind of thing that can run an API where you're interacting with lots of things in the world. So it's extremely limiting deployment to a kind of occasionally you compile
bundle up
software
an artifact,
and then send it out.
Right? Yeah, you have a guy with a briefcase come out with full of floppy drives, and he says, "Well, would you like to see these floppy drives?" Yeah, so that's not something that's very feasible for an online deployment. You can do things that are limited versions of this, though, and oftentimes you can have systems where you're developing in a more secure environment. You for example, don't have windows out to the outside and things like that, where someone with a camera can read your password while you're typing it.
Right. Yeah.
You can have that kind of security where you're doing some good stuff on the inside and deploy to a server room that is relatively secure and only talks to the outside through fiber.
Yeah, I'm slightly asking about these because I'm trying to figure out what is viable today? What's the state of the art? And I guess it seems like there are things that we can probably keep secure most of the time. The problem is that it's just massively reduced the functionality of these things. And so maybe what we want to do is find ways of creeping out the things that we can keep reasonably secure while still maintaining some level of functionality and interaction with the outside world. And that's kind of the really big challenge.
Yeah, I think that if you can keep most of your system inside these domains and you mostly talk through things I would talk about it like a gatekeeper. You've got some piece of software that talks to the outside and converts something into a language or a packet that is ideally formally verified or something like that to not produce bugs in your system. Then that's, I think, the best you can do really there is you can do data cleaning on the input to your system.
Yeah. Are there any networks that we really would have expected to be penetrated that, as far as we know, have not? I suppose the NSA kind of stands out to be as an example of an organization that, from what we've learned, they have an incredibly large repository of incredibly sensitive information that they've kind of nicked off of our emails and phones and so on. And they're obviously have a huge target on them. That other countries might be very interested in breaking into the NSA's networks. And yet, as far as I know, that hasn't happened. I mean, they might even want to do it just to embarrass the NSA. But somehow they've managed to not have that embarrassment happen. Do you have any thoughts on that?
Yeah, I think that's an interesting case. I think the NSA is very lucky in a sense where they're a great attraction for a security person who is interested in solving probably the world's greatest challenges. And so they absolutely have things like people who are actively looking at and inspecting the traffic that's going in and out of these networks and things like that. If you've got a team that is examining everything and they've got enough tools to do that, you can get a lot further than you can get with being anybody else, I think. And so this is actually one of the cases where AI might be interesting in improving information security, is doing things like these sorts of deep packet inspections, looking for suspicious activity, whether that's information being exfiltrated or, some kind of payload that's coming in. So we've seen some things that look like that.
Yeah. Okay, so you're saying like one reason why maybe the NSA could be doing better than almost anyone else is just the sheer amount of effort that goes into securing their networks, which includes like not only people trying to update the systems regularly so they're patched, but people who are kind of inspecting everything that's going on within the system so that if something dodgy begins to happen, if someone breaks in, they're likely to be detected and blocked like much faster than they otherwise might be.
Yeah. It also helps that the NSA is part of the federal government, and if you try and break into the NSA and they catch you, then they can send people with guns to your house, whereas many other companies can't do that.
Yeah.
Certainly not as directly. The other side of this is that the NSA has folks who are interested in things like breaking into systems. If you are a 14-year-old hacker who broke into some large system and you're possibly in danger of going to prison for a very long time, I imagine that you might get an NSA recruiter tapping you on the shoulder saying, hey, wouldn't it be nice if
you didn't go to
I'm
prison?
giving you probably one of the most exciting jobs of your life. So doing things like we talk about a penetration testing, trying to break into those systems is one of the best ways that you can verify that security. So you have sufficiently smart people, clever, like people who think outside the box, trying to break into those systems, and that helps you discover those vulnerabilities before somebody else does.
Yeah. Okay. Well, I started out this conversation feeling a little bit some degree of despair because it sounded like this was borderline futile trying to prevent this information from getting out. But it seems like there are people who are making some serious effort, and hopefully, maybe if we have years or decades to try to improve what the state of the art is, maybe we're not completely screwed. That any ML model is going to be like stolen pretty quick smart.
Yeah, I think there's some pretty exciting progress. I think that right now, if we were to, produce AGI in our kitchen, it would be stolen. But I think that if you don't have that case and the timelines are longer, then you have time to do things like build your own formally verified systems that are very robust to these sorts of attacks.
Yeah, can you explain what formal verification is?
Formal verification is like a logical technique for talking about the execution of a piece of software, or really an algorithm. And you would use something like this to describe the behavior that you want in a system, and then basically create a very, very long, complicated proof that proves that there are no vulnerabilities or unexpected behaviors or undefined behaviors in the system. If you look at something like, for example, the C language, which is a systems language that is used for producing things like the Linux kernel and other like really important pieces of software, there are certain kinds of operations that you can do that are just simply not defined in the specification for it. If you look at almost any piece of software, there are ways you can give it sufficiently weird, sufficiently well-crafted inputs that will cause it to crash, that will cause it to overwrite pieces of memory that you didn't expect it to. And formal verification is a technique for preventing those things going into software in the first place. Of course, it's quite difficult. You don't see very many large pieces of software produced this way, but we've seen some pretty interesting examples of things like microkernels that come out of mostly academic labs that are interested in this sort of thing, where you've got a kernel that has some very limited functionality, but is completely proven.
Interesting. Okay, so this is something that we kind of know how to do, but it's like quite challenging. And I guess the more complicated the program you're making, the harder it is to formally prove that there's no circumstance under which it might do X. There's no input that can produce X as an output.
Yes. If you think about the complications inside of a program, you have a lot of cases where you're multiplying and putting exponents on the complication of the kinds of inputs that might come into the system. And a good technique for making your program able to be formally verified is splitting up the input in ways where you can formally verify parts and then talk about things at that level of abstraction. So you can say that these parts interact in a particular way.
Okay. Is this a kind of new technology? I remember hearing about people bring up formal verification years ago, and I think they were talking about it with the sense that this was something that didn't really work at the time, but might get better in future. Is it an area of research where we're improving?
It definitely seems like we're improving. Yeah, I think that programming language design in general has come a really long way since the dawn of computing. So I definitely think that there's progress there, and it's a pretty exciting field to be working in. That being said, I think we will have to have some really significant advances in programming language theory to have formal verification become, a very accepted part of the tool belt.
Yeah. I guess I was saying I was optimistic because it sounded like there were a bunch of, or at least like some people were succeeding partially when it came to information security. But I guess we should only kind of be optimistic if we think that on balance, like information security or computer security is improving over time rather than staying static or getting worse. Would you say we're getting better, or at least like maybe building up the capability to in future become better at securing information?
Yes, I think I can confidently say that things have gotten better over time. Things have gotten much more complicated, and obviously like the surface has increased. But as that surface has increased, you've also gotten the incentives in play for people to secure things. Moving e-commerce online, moving commerce to e-commerce, having online systems that are handling large amounts of money has been a fantastic motivator in getting people to think about how they can write software in a way that doesn't get you broken into. When I was in middle school, we had some software on the Macs in the computer lab that didn't let me run, I think, NetHack at the time, which is like a text adventure game.
Yeah.
And I was pretty upset about it. And so at the time, it was like extremely trivial for me at like 12 or whatever to, boot this thing into a recovery mode where it didn't check for password. And then you could change the password in the password file because it wasn't very well encrypted and things like that. And that just wouldn't happen today, right? If you look at something like the MacBook, the M1 chip, a lot of the passwords are secured in a hardware chip that is specifically designed to resist this sort of thing, as opposed to on a file on disk. Now, that's not true of everything. We certainly see, for example, in the Okta hack recently, there was a Excel file that contained the password for a LastPass account, which is certainly something you don't want to see as somebody on the security side of things. So obviously, the last system to secure is humanity. So you can have as secure a system as you want. If you put a sticky note on the outside of your laptop that has your password that is going to be visible to somebody who is on a Zoom meeting with you, then perhaps your security is not so good after all.
Yeah. Well, I mean, I suppose you could have two-factor authentication. Use the keys that you have to physically have in order to secure something, so the password isn't so central.
Oh, for sure. Yeah, I think multi-factor authentication is very, very exciting, actually. Something where you can both prove who somebody is and what somebody has is pretty important. So we've seen some advances in this. For example, now there are more places that might require two-factor authentication, that might require two-factor authentication that isn't through SMS, and might even support something like FIDO2, which is a protocol where not only is the key that you're producing out of this hardware device specific to that device and that user, but it's also specific to the site that you're authenticating with as well.
Yeah. We'll come back and maybe do a bunch of security advice for individuals and organizations. Because I guess, I mean, some of that stuff is really quite relevant to how you can, in practice, secure a network that people are actually working on and actually doing normal work on. Or really, not secure it against the most persistent threat from all of the best Russian hackers, but secure it against like ordinary attacks.
Right. Yeah. Having enough things in the way that perhaps they will go and attack somebody else.
Yeah. Okay, so imagine you don't want to spill all of the beans on the security work that you're doing at Anthropic. But what's like one thing that people in the audience might not have heard about that you could do with the network in order to make an adversary think, maybe I'll go and hack someone else, or maybe I'll go and bother someone else's network because this is getting harder.
For a network specifically,
to be honest, anything to do with Anthropic's computer systems, or
sure. I think that one of the biggest things you can do as an organization to avoid people getting hacked is to give them hardware that you control and to have a unified fleet of hardware. So, for example, if you've got a fleet of computers that are all MacBooks, that are all centrally secured and have encryption on the disk, then you can limit the damage that's done by a hack that's, for example, to some Windows firewall or something like that to non-existent because you're only running on macOS. And you're also limiting things like, I went on AliExpress to buy a pink Blahaj plushie, or something like that. And it turned out that the vendor sent me a Word macro file or something that broke into my computer. But I did that on my personal device. And so now they would need to be able to jump another level into your corporate device. And you can do things like you can lock down the software that's on there. You can lock down the websites they can access. Please use an ad blocker. Ads are important for like the health of many companies, but if they're a legit company, oftentimes you can support them in other ways. And ad networks are one of the easiest ways for an actor to inject malicious code onto a site that might otherwise be safe. So use an ad blocker.
Yeah. I guess Anthropic is a reasonably new organization. It's kind of a year or two old. Is there anything important that you did in kind of setting up the way the systems work that secure it to some degree?
Sure. I mean, I think that talking about having corporate devices is pretty important.
Yeah.
I think another thing to think about is we used to talk about trusted networks and having things like a corporate network. And I think that Google's done some pretty good work with things like BeyondCorp, where you don't really think about a VPN or something like that for security. You instead think about identity-based authentication. So there's no such thing as a trusted network where you get on it, you no longer have to authenticate to grab files off of a shared SharePoint drive or something like that. You're always authenticating at every step. The other thing that we do that I suggest to every organization is to think about single sign-on, to make sure that you don't have your users managing passwords for many services, juggling passwords around where it can get very tedious for them to use a different password for every service. So using things like a password manager and single sign-on can help mitigate some of those flaws.
Yeah. Anthropic has appeared during the COVID era, which I imagine means that you've probably been working remotely, at least in part. Do you think as security becomes like an even bigger concern, as hopefully your models become more capable of doing important things, is there a chance that you'll basically have to stop being remote or have some kind of physical restriction on access to models or data in order to like ensure that they are sufficiently secure?
I would not be surprised if that's something that happens in future. That being said, I think that we've actually had some advantages in terms of starting out with this remote policy. You can't have a trusted network that everybody's on if everybody is on their own network. So it's been important in sort of driving forward the identity-based authentication policies there. So I agree that I think physical security is going to be quite important in future. And there are sorts of mitigations that you can't really express remotely. But yeah, I think that's in our future timeline.
Yeah. I guess for a while, people have talked about how improved machine learning or improved AI could lead to a kind of security apocalypse situation where AI is just so good at discovering vulnerabilities in systems that they would suddenly become like much more transparent to a wider range of actors than they currently are. And then I guess the response I've heard is like, well, if the bad actors can do that, then surely the good actors can get the same model, like find the vulnerabilities and patch them pretty quickly. So it's actually not obvious whether this helps with offense or defense. Do you have any view on whether kind of ML itself is making security better or worse?
Hard question. I think that probably it's going to make things better. And the reason I believe this is I think that a lot of the work that's being done at places like Apple on security is also driven by ML. And I know I've specifically called out Apple a couple of times here. There are other things that, like, for example, like the Google security blog is fantastic to read. But yeah, I think that security researchers getting access to more sophisticated models is going to be quite positive. And I also think that there's a possibility that we can use ML models to drive formal verification forward and to drive adoption of programming practices that are more defensive, that are harder to break into with ML. So I think that it is definitely a spy versus spy sort of scenario where the technology is very much dual use. And it's certainly going to have some growing pains as these things become more capable. But I'm hopeful that that's going to result in a more secure, while still being usable future.
Yeah, yeah. To what extent would computer security benefit from just more money being spent on it, basically, by the relevant actors? I ask this because I think I remember reading about someone who got paid a bug bounty, basically, for finding this horrific flaw. I can't remember if it was in like Mac OS or in the iPhone or something like that. But plausibly, they could have sold this for tens of millions, hundreds of millions of dollars because of like the power, basically, of this exploit. And I think they got $1 million or something from Apple for going through their bug bounty program.
It's pretty good. I see thousands of dollars often, or hundreds.
Right, yeah. So I think this was one of the largest, but it was nevertheless like much less than you might imagine they might be able to sell it to criminals for or to state actors for. Mm-hmm. I suppose, of course, there's like Most people would rather sell the thing to Apple, I imagine, all else equal, and they'd rather probably not be on the run from the feds. But would it maybe just help to like throw more money basically at getting people who are kind of on the fence between being good actors and bad actors to be good actors?
That's a great question. And honestly, I'm not sure. But my guess is yes, it definitely seems like something where we've seen bug bounties show up more often. We've seen security researchers get paid better, and I think we've seen an increase in the resulting security and a decrease in the prevalence of people trying to passively break into systems for money instead of getting to work on a team of people who are all trying to break into things for money and not going to jail.
Yeah, yeah. I guess I have this stereotype from the past that, you know, computer security is bad enough that, like, you know, a motivated 14-year-old who, like, you know, hasn't been to university yet but just is really into computers can probably do some interesting hacking, like break into systems that you'd be kind of surprised that they could get into. But I wonder whether that might actually be kind of an outdated stereotype, and whether, like, perhaps things have improved sufficiently that a 14-year-old actually might struggle to do anything interesting at this point. Do you know where we stand on that?
I think that stereotype is still quite accurate. And broadly, there is more software than there used to be. So a lot of the targets that were on that lower end of the security spectrum, there just are more of them. So I think that until we find ways to create secure systems by default, instead of having to do security as more of an afterthought, we are going to continue to see situations where a script kiddie with a piece of software that they downloaded off of GitHub can do a vulnerability scan and deface some website or something like that. I think it's a lot harder for them than it used to be to break into things like, you know, whitehouse.gov or something like that.
Yeah, I see. So maybe the top end has gotten more secure as this has become more professionalized, but there's so many more things on computers now in general that the number of things that are not secure is still plenty.
Yes. And I think in some ways this is good. I think that, like, having systems that kids are able to break into is in fact a good thing. We've seen some really cool stuff in terms of there are websites where you've got a kind of a capture the flag scenario where you're meant to try and break into one level and then it gets to the next level, and, you know, then there's some key that you have to find for the next one. And these are actually really, really fun. And I think it's a great way to get kids interested in security. So I think that having systems that are targets, I mean, I would obviously not condone somebody trying to break into arbitrary websites, but certainly there are tools that are actually fun to do this with.
Yeah, how illegal is it to break into a website or something that doesn't matter that much, just as a matter of kind of getting practice and training and this, you know, assuming you don't do any damage, whatever?
Very illegal, and you shouldn't do it.
Okay, all right.
But long story on that. So I would say that if you're interested in trying to do some kind of vulnerability testing, I would contact that website and ask them, because a lot of, you know, Silicon Valley mindset is like, ask for forgiveness, not permission. Computer security and data loss is not one of those things.
Yeah.
So
it is a crime.
It is. Yes, it is what one would call a crime. So I don't recommend it.
Right. But you're saying if you contact a random website and say, I think you might have a bunch of vulnerabilities, I am training in this, would you like me to try to break into your systems and then tell you what to fix? Enough of them will say yes, that this is a viable method.
I think not very many people will say that yes to you if you're not somebody with like a background in this sort of thing. And if you don't have a background in this sort of thing, then I would recommend looking at some of these capture the flag websites, some of these other sorts of things where somebody has actively set up a really interesting puzzle for this. And I imagine that the NSA has some programs around this if you're interested and on the younger end. So.
Yeah. You know, if there's young people in the audience who are interested to get more, try their skills at this sort of thing. What resources can you point them towards? Is there a like Hacker Monthly like magazine or I don't know, a podcast they should be subscribing to?
So a couple of things that you might want to think about. There's a thing called the CVE, which is a centralized database for talking about various sorts of vulnerabilities in computer systems. Taking a look at the sorts of things that are there can be quite informative. Oftentimes they have exploits that come with them as a proof of concept, you know, for being able to break into those sorts of systems. So that's a good way to get acquainted with the sorts of vulnerabilities that people do introduce into these systems. So that's one thing. There's a site called ctf101.org that talks about, you know, forensics and cryptography and exploitation and reverse engineering and that sort of thing. That's a pretty good resource. There's a thing called Metasploit, which is another database of exploits that you might want to look at. There are a lot of different kinds of capture the flags. Those specifically, I think, are really good. I think there's nothing like experience in many, many computer things. It's very easy to read about something and go, oh, that makes sense. And it's a lot harder to put it into practice. And having a system that's live that you can try stuff on where they won't call the police to your house is really good. So trying those is great.
Yeah, let's start in with this question. The obvious way to reduce info security risk is to beef up your own security. But another is to disincentivize actors from attacking in the first place. Are there any good ways of doing that other than the obvious of the criminal justice system?
So are you're talking about like counterintelligence type stuff? You know, the sort of having something that will damage their computer if they log into it or something?
Yeah, I'm actually not sure what they're thinking of. I suppose if you want to talk about options for using criminal justice to discourage people, that would also be good. But I guess I read, when I was reading about the Nvidia hack that we were talking about earlier, the hackers themselves wrote that Nvidia tried to hack them back in order to, I guess, destroy their systems and then destroy the data that was on them, and they were miffed about this. So I don't know whether there's any kind of counterattack thing that you can do that make it less appealing to target you in particular.
You know, that's a great question. I don't know if there are automated systems for doing this sort of thing, because you might be a criminal breaking into my system, but if I try and break into your system and succeed, that is also a crime still. So I think there are some difficulties there, though oftentimes I would imagine that it wouldn't be prosecuted very heavily. I think that this is probably not the road you want to go down unless you have people in mind who would be interested in actively doing this sort of security thing. But yeah, I think in NVIDIA's case, they specifically wanted to destroy an asset, right? They had a piece of intellectual property that destruction would result in the hack being neutralized. Whereas oftentimes if you're, for example, Amazon or something like that, you might just lose a bunch of money, right? You might have a bunch of things stolen that a counter hack isn't really going to save you from.
Right. I guess this person might have this in mind in part because I think this exists at the like state versus state level, where one country will hack another, and then they get annoyed, and so they kind of retaliate in kind. I suppose knowing that retaliation is possible helps to put limits on what countries will do to one another, basically.
For sure, a mutually assured destruction policy is certainly something that's important in a broader game theoretical sense. I think that most companies and most individual actors do not have the capacity to do these sorts of things, and that you'd be better off spending the time that you'd spend on that in decreasing your attack surface, limiting the software that you use, and that sort of thing. For criminal justice wise, I mean, I think that in financial systems and things like that, we talk about having compliance and auditing and having very clear policies on what misuse of a system looks like, such that we can do automated detection, such that you've got some recording of some kind of bad behavior on your computer systems, and it is very clearly something that we told you not to do, and is very clearly an abuse of the CFAA. So that's something where, I guess on the criminal justice side, keeping good audit records is pretty important for being able to successfully prosecute this sort of thing. Oh, and get on the FBI InfraGard list. There's a mailing list for information security professionals that is free. It comes from the FBI and oftentimes has some pretty interesting stuff. They recently had a webinar, for example, on cyber attacks related to the Russia-Ukraine crisis. So.
Oh, nice. Okay, yeah, we'll track that down and stick up a link to that in the show notes.
Yeah, you can find that on YouTube, actually. So one of their calls was recorded.
To what degree is it still like a major problem that people just don't patch their systems when there's security updates?
This is very, 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 very prevalent. Okay. Certainly, this is something that it's very inconvenient to patch systems. You have to take them down. You might have to test them. There might be something in there that isn't something, at least a change in behavior.
Compatible with the security update.
Yeah, so I used to work at the NCBI. It's a National Center for Biotechnology Information doing systems administration on some of their large systems. And we were trying to upgrade our systems from one version of CentOS, which is an operating system, to another. And in the process, it changed this core system directory component. And it wasn't a security update, but it broke a major piece of functionality that we used to look up users on systems. And this was an incredibly frustrating thing for me when I was working there. And in fact, I didn't solve it. I instead left the company. Not because of this, but I had other opportunities that I moved on to. But it is, I think, something that I did not solve in my time there. And that was something I worked on for several months. So especially when you have many pieces of software interacting, patching a system is very non-trivial.
Right. Yeah. To what degree is this kind of an important thing for the whole software world to be improving? Is finding ways of doing security patches that don't break other software and don't break systems so that people are more willing to patch things faster, and maybe they can even just be set up to occur automatically. Possibly this is just like fundamentally not possible because sometimes the security patches require changing something, and changing that thing then breaks something else.
Yeah, I think that the incentives just aren't in place for people to make a big effort to maintain older versions of their software with security patches. If you look at something like the Linux kernel, this is a project that does this quite well. There have been several versions of the kernel. I think we're on 5 something right now. Don't quote me on that. I would have to check. But there are several long-term support versions of the kernel. That might be the 4 series, or it used to be the 3 series, where when a security vulnerability was found, maintainers would backport that fix from the latest version to all these long-term support branches. And that means that if you have software that depends on a particular version, you don't need to upgrade and have to deal with other kinds of compatibility issues to patch your kernel. All you need to do is apply this one fix. And more software should work like this. The concept that you have to be on the latest version of software as opposed to up to date with your security patches is a thing that I think makes being up to date with security patches much more difficult.
Yeah, I guess this sounds very expensive for the Linux people. I guess it's cheaper for everyone else, but is creating a whole bunch of work, making sure that you patch every previous version of the thing with the current security updates.
Yeah, and it's something where you've got a long-term security policy. You're only going to let it last for, a couple of years or something like that, maybe a little bit longer. So there are ways to mitigate how many versions of the software that you're keeping track of. So I think it's possible, and I think it's definitely worthwhile. And I imagine that there are ways that you can grant to open source projects that are relied on to help them have the capacity to do these sorts of things, to backport these fixes, to when there is a security problem, not force people to jump 3 versions of the software.
Yeah. Okay, let's talk now about your other big project, which is Hofvarpnir AI, which has gotten funding from, I think, the Effective Altruism Infrastructure Fund, and I think now Open Philanthropy as well, and a bunch of other people. And I guess at the same, while we're talking about that, we could maybe talk about this issue of system architecture and compute as well. Yeah, what is the goal for Hofvarpnir? What's it going to end up doing?
So it's Hofvarpnir Studios. Our overall goal is to... we think that AI compute is kind of a carrot in terms of driving how research works. And so what we're trying to do is we're trying to build the capability to run models in a very consistent, very secure way, and offering that capability to AI safety researchers. So specifically, we're working with folks at Chai, and we're working with Jacob Steinhardt, also at Berkeley, some folks at UT Austin, Mila. I think we're hopefully talking with some people at Princeton. And I think we're looking at people who specifically are working on safety, that we've seen have a proven track record of publishing safety research. And so that's I think our goal is to have this differential capability available to them, because oftentimes they're not as well funded, or in general, when it comes to crunch time, right before a conference submission deadline or something like that, oftentimes all the compute's gone. You can't get your P4Ds at Amazon. Yeah. So having these extra resources available means that these folks are able to get that little leg up. And I think that's what we're doing, because, the reason that we actually did this is because Shauna, back in a few months ago, got a 3090, which was a very exciting graphics card. And I think she mostly got it to play Half-Life Alyx or something like that. Anyway.
Good game, by the way.
We got these, it's a pretty good game, yeah. So we had this graphics card, and we had these friends who are safety researchers who were struggling to get compute at their own labs. And we ended up doing a remote connection to her home desktop with this one graphics card, because it turns out that was valuable enough that putting in this effort helped them get their research moving forward. And we were this is ridiculous. This is absolutely the sort of thing that an organization should be doing, and nobody's doing it. And then we looked at each other and we were we should do that. So that's how we got started. And, the Effective Altruism Infrastructure Fund was pivotal in helping us get those first machines online. And now I think the OpenPhil has been helpful in scaling that even further. So I'm very excited to see how this work turns out and making sure that we're staying with safety. And so I think part of that ends up looking like working with the researchers who are currently using our compute to drive decisions about who else gets to use it. So because alignment is important. And I know that, for example, I can't claim to be an expert on safety, but I have friends who are. So I can ask Sean, I can ask, Dr. Steinhardt, ask folks at Chai, that sort of thing.
Why on earth is this thing called Hofvarpnir? Okay, so I should spell it out, I guess, for people who want to Google it. It's Hofvarpnir. Why?
Mm-hmm. Yeah. So one, it's a horse from the Norse mythology.
Okay.
But the reason that we called it this is very tongue in cheek. Kind of, there's a piece of fiction called Friendship is Optimal, where there is an AI foom essentially in here, and it was developed by a company that's called Hofvarpnir Studios. Okay. And so we took this sort of as like I think that if somebody reads that fic and goes, well, we should totally do that, at least they can't call it Hofvarpnir. Two, I think it's appealing to a certain kind of I think it was one of the things that pointed me at, safety might be important for these AI systems. So I think it's sort of a call out to Iceman, who wrote that fiction.
Nice. Okay.
Yeah.
So the basic idea is build, collect a whole bunch of compute that academic research scientists can use if they want to do research that is more tilted towards improving safety and alignment than it is tilted towards improving raw capabilities of AI. Mm-hmm. And I guess the vision is there's people who wanted to do this research, but actually they were lacking the compute, so it was slowing them down. And then I guess also that the availability of this cluster might be a sweetener for people who are kind of on the fence about what sort of work they'd like to do. Because if they're doing something that other academic safety and alignment focused people think is great, then they might be able to get access to this cluster. And effectively, it's kind of getting a grant on the side.
Yeah, for sure. And I mean, I think right now we're focusing on people whose work is entirely safety, because we're not really, I think we're not really equipped right now to do a good evaluation of some of those more edge cases, but that's definitely something that's down the road if things go well. There are two other things that I think that Hofvarpnir is important for. One, I talked about it being quite difficult to get access to the amount of compute and access to these large systems, especially as a beginning infrastructure person who might be interested in AI safety. So this is providing a sort of a playground where there's somebody who's had some time to think about these things. And we've got opportunities to hire some of these people and train them and hopefully keep them within AI safety. So in some ways, it's an on-ramp there. The other thing is lots of folks already have GPUs. Many labs have GPUs, but those GPUs might go underutilized because you might only use them, say, 50% of the time, right? You might not always be running experiments on them. So part of what we do is we also try and incorporate some of those existing resources into that same cluster and make it possible to schedule across these several spines within this cluster. So that way, if you, I'm going to keep saying Dr. Steinhardt and Chai partially because they are our funders and also because they're doing a lot of really exciting safety work. So if Dr. Steinhardt wants to run an experiment that's on more computers than he has available and Chai isn't actually running some stuff on some of their computers, then because we have this unified platform and because we've, containerized their workflows, we've done a bunch of infrastructure stuff to make it possible to run these transparently, you can schedule your workload to take advantage of these additional computers that wouldn't otherwise be available to you. So think about it like defragmenting these otherwise siloed pools of compute and freeing those specifically for AI safety.
So you're telling me there are still GPUs sitting out there idle rather than mining crypto?
I know. Who can believe it?
I suppose they're in university, so maybe it's hard to get permission to use all of their electricity to get some ETH or something.
Yeah, I don't think we'll be mining crypto with this GPUs anytime soon.
Yeah. Okay, I know this isn't particularly your area of expertise, but let's talk a little bit more about the kind of capabilities versus safety issue, because it's something that came up in discussion online. What is it that I was going to interview? I guess for listeners who haven't heard these ideas before, there's distinction that people draw between trying to make AI capable of just doing things in general, like, I don't know, being good at dealing with people, being able to get people to do what they want, and then, which I guess people call capabilities. And then there's talk of like safety and alignment research, which is more about ensuring that whatever a system is capable of doing, it ends up doing what you want, or like using the methods or achieving the outcome that was actually desired by its handler or deployer. Now, some people kind of dispute this distinction a bit. Some people think that these two things kind of go hand in hand, maybe more than some other people do. The argument there being that, well, something's not really capable if you can't actually give it instructions to do what you want to do, and it goes off and does something completely different and random. That doesn't sound super capable, and it's also not aligned. But there's plenty of other people who think that there is kind of a distinction here, that there's some things that you could do that would add capabilities but not do very much to improve alignment, and vice versa. I guess, yeah, how worried are you, I suppose, about the possibility that your work either at Anthropic or at Hofvarpnir could end up improving capabilities maybe more than is your like desired outcome?
I think there's a chance. I think that certainly there are a lot of unknown unknowns in research, and it's possible that we would differentially improve capabilities. Part of the reason we're also providing additional compute is because I think that a lot of the good research is done on larger language models. I think that there are things that show up in large language models that you don't see in lesser models.
Yeah, could you say a little bit more about the lines of AI safety research that are most bottlenecked by compute?
Oh, yeah, sure. I mean, I think anything with large language models is pretty bottlenecked by compute. Anything where you're doing, I think, reinforcement learning, you might need... you're doing something kind of pathological, right? With how much you're able to use the GPU versus CPU on systems. So I think both of those are pretty bottlenecked by compute.
Yeah, it's interesting. So this issue of the risk that people trying to improve AI alignment could accidentally on net make things worse by contributing to AI capabilities and just speeding up progress in AI in general. This has been an issue that people have talked about. I mean, I think I remember people talking about this 10 years ago, basically.
Yeah.
And it shows up in, biology or like biotechnology as well. This issue of like dual use and the fact that if you're doing research, then kind of almost by definition, you don't know exactly what you're going to find. And so like, couldn't you accidentally make discoveries or possibly even predictably make discoveries that are actually going to hasten the deployment of various AI systems? We've talked about that, I guess, with Chris Olah at some length, so people can potentially go back to that interview if they want to hear his view on that. I guess a challenging thing with this disagreement, in as much as people disagree, is that it seems like the disagreement is quite often driven by quite deep worldview issues, where the people who are most keen to just push ahead with AI safety research and feel pretty positive about it are folks who think that AI alignment is reasonably likely to succeed, that current AI systems are kind of within shooting distance of being made aligned. And so they feel pretty good about like pushing ahead and just making more capable systems and aligning them as we go. There's other folks who think that the current ML architecture is just not going to be possible to be made safe ever. Maybe they also think that dangerous AI systems, things that could actually do damage, are likely to be deployed in the near term. And ideally, they'd just like to see kind of everything slowed down so that there's more time to really pick a different direction in which to go. People have like different fundamental worldviews like that, or like different, quite different visions for how the world is and how it might go in future. It's challenging for them to just like discuss these surface issue concerns and then like reach an agreement. They kind of have to coexist peacefully, and I suppose hope that over time, like one of them will be shown to be right, and actually people will converge on having a better understanding of what the risks are, if indeed they are real. Sorry, is there a question there?
Yeah, I think that was more of a statement than a question. But yeah, I think I agree, Rob. I mean, that being said, I think folks who think that the underlying architecture of especially large language models is unalignable by its nature. I'm, vaguely sympathetic to this worldview in some ways, but even if this were to be true, I don't think that would change what I'm doing here, because I think in a lot of ways it's at worst a harm reduction measure. At worst, we are giving the folks who are working on, fundamentally different architectures more time to try and create those things. And the other thing is, I think in some ways it looks kind of arms racy, right? You might be able to say that, in the US, you shut down this research somehow. You get enough senators on your side to come out and say, you can't do this anymore. It's national security. that's not going to stop that research from happening. It's just going to drive out the safety researchers, right? I think it's almost any kind of thing that looks like that just means that you only have bad actors. You only have, sufficiently motivated capabilities actors doing this research. And I think that's not what we want as a field. I think we want safety to be driving things forward. We want to have results that come out of things like, Chris's interpretability work. The finding of induction heads is not something that came out of capabilities. It came out of looking at how to make these models interpretable. And so I think that there's a large amount of value to be had in doing that research, even if it turns out that these are fundamentally not fully alignable.
Yeah. Someone, an audience member wrote in with the question, is the typical engineer working on non-safety research at OpenAI or DeepMind increasing or decreasing the odds of an artificial intelligence-related catastrophe? This question definitely puts you on the spot. It's one that I know many people are not super keen to answer because they could offend their friends. But
that's a really hard question to answer, I think. I think that if you come at things from the perspective that all capabilities work of any kind is negative, then I think, and it is of itself increasing the odds of an AGI-related catastrophe, then that would be, I think, an answer to your question. But I think that's not my model in some ways. I think that having capabilities that are within organizations that have pledged to treat things responsibly are probably decreasing these odds. Things like the OpenAI APIs for accessing models mean that more people have access to language models in a way where there's a gatekeeper, where there is a layer of safety and a way of, imposing values onto the users of that model in a way that is fundamentally not true if you have a large number of actors. And so I think that it's very hard to say. And I would say that I think certainly there are safety researchers at OpenAI. Certainly there are safety researchers at DeepMind. And I think that those organizations also are thinking very thoughtfully about these things. And I'm hopeful that they are decreasing the odds of an AGI-related catastrophe. If you made me answer that question, I think that would be my answer there.
Yeah. It's certainly the case that it's not only possible for the safety orientation or the thoughtfulness or the niceness of the actors working on AGI to improve. It could also get worse over time, or people can just become more scattered and more arms racy over time, which is definitely a factor that complicates this question.
Mm-hmm. And I think that in some ways there's an evaporative cooling effect if you say that you're never going to work at a place that has any capabilities, because then all you have working there are people who are purely interested in, let's crank it to 11. Let's drive this forward.
Yeah.
And I think that having safety researchers there is important, and having this sort of collegiality with other organizations and having, standards and being able to talk to each other about these things is important. So I don't know. I think that the typical engineer there is probably decreasing these odds just out of a matter-of-fact consolidation of intellectual capital and things like that, and capabilities within a smaller number of folks who can then cooperate.
Yeah. Well, I'm glad we've wrapped that one up. I'm sure this debate will never come up again.
I'm for sure.
Something we haven't talked about yet that I'm really excited to learn more about is kind of what interesting design choices there are when you're putting together a cluster to try to get as much useful compute out of when you're doing big ML models. What are kind of the interesting optimizations that you could make?
I love this. This is one of the best parts of my job. So for making a cluster for ML models, I think one of the things you need to think about there are two basic components, right? You've got these units that can do floating point operations and matrix multiplications. And you've got cables that are connecting them together at a certain speed, right? And you've got some memory, that sort of thing. So the design choices that you're making trade-offs between mostly price and how much bandwidth you have between these units. And the other thing is a design choice on the software end of are you writing your software in a way where it can easily be distributed over multiple GPUs and things like that. So that's also a design choice, though mostly on the software side. So those are some things. And some logistical choices. I mean, you want to try and run your stuff where the power is cheap and the the real estate is cheap. It turns out that rent for a large number of servers is actually any
Big cost.
Uh-huh. You also want to think about how easy it's going to be to expand. So when we started out, Hofvarpnir made a pretty big mistake starting out, which was that we thought, well, we're going to so as a bit of background, almost all of my systems that I run for myself are run on hardware that I own in like people's basements and stuff. And it's this global network of like lots of computers that are all like talking to each other, but they're all on residential connections and they have like interruptions and stuff like that. And this turns out to be really cheap when you're a college student, and it's a great idea for like anyone who's trying to work on a system and they're trying to do something scrappy. I recommend doing that first. But it turns out that like time is the limiting factor in some ways. And so when we first got our EA infrastructure money, we were like, okay, we're going to buy all these components ourselves and assemble. And then we had some like technical difficulties, and we had some difficulties with like the provider not having the right width for the racks and stuff like that, and all sorts of like really weird integration issues. And it turns out that like it was better in the end to go with an integrator for like future expansions, because it means that we can ask them to say, okay, we're going to use these standardized units, and I just want 4 more of them. Like, we're just going to put them right next to each other and that sort of thing. Going back to the design thing, though, the bandwidth does become a concern there, because you have a limit to how much bandwidth a certain switch can carry. And you might want to get a more expensive switch if you think that your cluster is going to expand more. So that's one of those things. That's a more direct design choice.
Yeah. Okay. So I'm just trying to picture all of the kind of the various different trade-offs here. I guess it seems like one of the key issues is all of these different chips kind of talking to one another or sharing preliminary results with one another in order to kind of coordinate. Then the natural way to solve that is just to stick them all in the same place. Can you mostly not do that because you want to like bring together lots of different chips that people happen to have like locally in their own research center?
Yeah. Hofvarpnir is very weird because we don't have like one cluster. We actually sort of have essentially federated clusters. You've got these clusters of machines that are localized, and then we schedule across them. So I've been doing a lot of work in writing some scheduler stuff, which hopefully I'll be able to make public at some point, for doing this, for marshaling these jobs and making sure that they schedule correctly across multiple diverse groups of machines with different kinds of capabilities. So for example, some machines have more powerful graphics cards, some of them have access to fast storage, some have more memory, better CPUs. They're all over the place. My job at Anthropic is significantly easier in some ways, even if like some of the scale problems are harder.
Yeah.
Because all the machines are the same. So Hofvarpnir is a lot closer to the stuff that I'm used to, where most of the problems are, can you make the things work? So.
Yeah. Okay, so with Hofvarpnir, a key issue is like, how do you get lots of different pieces of equipment to all talk to one another, even though they have like internet connections of varying quality and I suppose different kinds of hardware? What are the kind of the key design trade-offs that you face with Anthropic, where I suppose things are more centralized?
I think a big problem that we have is deciding how big of a computer we need to run certain kinds of experiments, because this determines like really big price numbers. So I think that's like probably the biggest concern, is like deciding how big it needs to be, because depending on the scale, various parts of the software or the hardware might start falling down. You might need to have a different kind of network topology to support things. If like certain kinds of bandwidth are more or less important to you, if you're trying to get better arithmetic intensity on the accelerators, then things look very different. So I think that does that answer your question there? Yeah,
I think so. It sounds a little bit like the trouble that you have when you're renting an office for 5 or 10 years and you don't know how many staff you're going to have.
Exactly. Yeah. In fact, we had I think an issue with this where we actually ended up, I think we rented 2 floors, but we didn't actually fill both floors. And so like, I think we have some costs in terms of rent.
Yeah.
Because of that, for example.
It's a classic thing that kind of organizations go from having a glut of space to an extraordinary scarcity of space, and then they like expand in some lumpy fashion, and then suddenly they've got like way too much space again.
Yeah, I mean, I think this is a classic systems architecture problem in some ways, because it's not easy to add additional units of space for your employees, and there's like some cost to not having those be contiguous. But then there's also a cost for pre-allocating that space. And I think this is exactly the same with GPUs, right? If you have these separate clusters that are, not geographically the same, they might have a different number of GPUs on a fast connection, then you are limiting like the total size of collaboration or matrix multiplications, right, that you can do. So yeah, they're actually quite comparable.
Yeah. Okay, so you talk about increasing the arithmetic intensity of the operations or the system. Can you explain what that means? It's possible the answer is no.
No. It's basically just saying that if you've got an accelerator, it's got a processor, you can run a certain number of instructions per second on it, theoretically. There are various things that influence how many things you can actually do in practice. So if you've got a laptop, right, it's not running at 100% all the time. And that's fine. You can have like lots of extra space there. And that's actually really good for a laptop. But it's not good when you've got a data center scale computer that costs a really large amount of money. And so getting the speed of the models depends on like finding the bottleneck and, hammering at that and making the software able to push more instructions faster, push more memory in the correct ways, store various kinds of caches and that sort of thing. So arithmetic intensity is referring to like a single measure of that efficiency.
Yeah, I see. Okay, so I suppose at a high level, I imagine the thing that you're trying to avoid, like in the design of this entire thing, like at each different stage, is that you don't want to have a chip that is sitting there that could be doing more operations, but it can't get the instructions in to the thing. So the task has had to be routed somewhere else because, say, it didn't have enough bandwidth in order to send the instructions there. Or maybe it was just like poorly designed in terms of where it routes things. Or maybe it's like done a task and now it's gotten stuck with a bunch of the output, but it can't like send that where it needs to go.
And so it's just
so it
can't get new input.
Because it can't get new input. Yeah. So it's that kind of thing. So it's all of these like, you want to like have everything kind of working at the same pace, kind of, so that
exactly.
the kitchen works smoothly and you don't get like a bottleneck. We've got like two. I'm not sure whether anyone's played what's it called, Overcooked.
Overcooked, yeah, absolutely. I actually love that. Overcooked Factorio. There are a lot of games that like are very appealing to the systems designer in my brain. If I can't program anymore, I will still play Factorio for some reason.
Yeah.
So
the basic idea is you're trying to design a system which basically works at maximum efficiency because like the amount of all of the different things coming in and out is matched up such that you get the maximum output at the end without any like lax capacity or something getting stuck. Yeah.
Exactly. Yeah. So you're minimizing the amount of slack and you're maximizing the online time of the most expensive part of your system.
Okay. Okay. So you have to think about you have to think about the shadow cost of something not being used, basically financially or in terms of electricity or space or whatever else. Yeah.
Yeah. All sorts of stuff. Exactly. So it's just a really big optimization problem. So it's great. I like it a lot. You've got these very specific metrics that you can measure. You can like actually like down to the clock cycle, like think about how your software is going to run and then determine an efficiency number compared to whatever the peak efficiency that you might be able to get out of a chip.
Yeah. So you've kind of suggested that, I mean, I can see why this seems super fun. This seems like playing Factorial. It seems like playing a computer game in a way. You could get really hooked on it. But you think people haven't quite cottoned on to how exciting this aspect of AI is, like designing the actual equipment, doing the engineering, doing the architecture design to make things work smoothly.
Yeah,
maybe one day people will cotton on, but they...
I hope so. I mean, I enjoy these problems and I enjoy being like a person who's valued for working on them, but I think in a just world, this would not be the case. I think that everyone would be excited about this. And I think if you're interested in infrastructure, you probably need to have a pretty good frustration tolerance for some of these things, because it's not all the sort of the fun spreadsheet part of things. Gosh, I can't believe I said that. But
no, I totally understand. I'm on your team on this.
Okay. But it is also like the implementation, because it turns out that, this rack that you bought actually has, a width that is 1 centimeter smaller than it was otherwise advertised to be. And so the faceplate of the machine that you're trying to put in there, like the physical geometry doesn't work. This actually happened to us with the machine. We just took off the faceplate and this fixed it. But it was one of those things where like there are all sorts of many, many moving factors in a system like this. So
yeah. Completely random question. Is it the case that like specific transistors on a chip can break and that the chip can detect this and just like routes operations away from those transistors?
Yeah. So there's this project called Cerebras, which produces a chip that's called the WSE2. It's 56 times larger than the largest GPU, has 123 times more compute cores. It's a beast. It's a crazy project. I'm very excited to see what they're doing. The way that this works, though, is that if there is a single subunit on that chip that fails, then you can route around it. You can treat these sort of as interchangeable. And so, yeah, so that is in fact a thing that people are doing. And especially in a large distributed system, not even on the chip level, you can see like a certain server or a certain some component of the server fails. And one of the reasons why we care about things like Kubernetes is for scheduling a workload across a distributed system in a way that is resilient to failures and limits downtime or capacity sitting idle. So it's a piece of software that we use specifically for doing this.
Yeah. At a high level, like what kind of efficiency gain do you get designing a cluster well versus designing it in a garbage way? I mean, is it like twice as efficient, or more or less?
I think you can go more than that. I think like there's a lot of efficiency gains to be had. So, for example, like assume that you have. Let's talk, I guess, about the difference between if everybody had their own GPU and you've got all the GPUs in a big pile. So, assume that like I'm a researcher and my lab gives everybody an A100 chip. I'm only running experiments, 20% of the time or something like that. But when I am running experiments, I'm running several of them, right? I'm doing something where it's like a scan of various kinds of parameters, and I want to run multiple experiments. I have to do those in serial if I only have one graphics card. I could do them in parallel if I had access to a cluster, because chances are, most of the time, people are not going to be simultaneously trying to use their GPU. You can assume that they're going to use it maybe, say, 40% of the time or something like that. I'm making that number up. You would need to determine that. But that's one of those things where having more things interconnected and interschedulable means that you can get better throughput.
Yeah, I see. I guess we haven't explained like serial versus parallel, but it's basically this idea.
Yeah, if you do like one experiment at a time versus you do them all at once across multiple GPUs, basically.
Yeah, I suppose earlier you said kind of some software is designed such that it is more parallelizable, whereas other ones, or maybe that's more effort to ensure that things are extremely parallel.
Yes.
Is that right? Okay, right.
Yeah, absolutely. I think it's very easy to think about the execution. Well, it's maybe not easy, but it's certainly easier to think about the execution of a program as a series of instructions that execute in a row. And you're doing one thing logically and then another. Whereas when you're writing something that is designed to be run on, a data center scale computer, or, I mean, even if it's something that's meant to run on 4 cores on your CPU,
at some point you've got to break it up.
You have to think about, you've got to break up the problem into sub-problems that can then be solved simultaneously and brought back together. And that's just quite difficult to do.
Yeah, okay. So that's another margin of potential improvement, is improving the software to allow more cores to be brought on simultaneously. Yeah.
Mm-hmm. Yeah, absolutely. And I mean, especially like in machine learning, you talk about various kinds of parallelism. You talk about like the node level or the chip level, or all sorts of stuff like this.
Yeah. Okay. So if you're talking about, increasing the efficiency of the use of the hardware by like multiples, then I guess that explains why this is such an absolutely crucial issue, because the hardware is like, I mean, I guess I don't know whether like what is the division between like spending on wages versus spending on hardware and compute in various different forms. But I think like the compute is now a massive part of all of the costs of any AI related project. And so if you can kind of double the efficiency of that, that's like, huh?
It's $24,000 or something like that for an A100 GPU. Like that's you can get you can get a lot of grad students for that. Right. So the compute is horrendously expensive.
Yeah, I imagine that wages then for people who are great at server architecture or like compute architecture are getting bid up.
I'd say they're pretty good. Yeah.
Okay. Cool. All right. Well, maybe we'll stick out some links to some job openings. In that field.
Maybe hit levels.fyi for this.
Yeah. Is Hofvarpnir hiring at all?
Hofvarpnir is hiring for junior. We're sort of in a special case where we're trying to hire for specifically junior candidates who maybe had some experience in DevOps but are interested in learning more about it. So yes, that's what we're hiring. I think we're trying to hire right now one full-time, as of time of recording, for this, who would be doing like support stuff for this sort of weird heterogeneous cluster. Because both Shauna and I have full-time jobs, and it turns out that running, 1.5 jobs all the time might be a little bit stressful sometimes. So,
how many roles do you envisage there might be in Anthropic in that kind of work in the fullness of time?
I think that for junior candidates, it's hard to say. If you already know some stuff about this, then I think that we could easily absorb another 4 or 5 people that are doing the sorts of things that I'm doing and
right now,
not slow down. Yeah, right now.
let alone in the future. Yeah.
Let alone in the future. I think it's really hard to say in the future. It depends significantly on, how well we do and what our results are. So I can't really talk very much about what future plans look like. But certainly right now, I think we could take some more folks.
Okay, let's talk now about, I guess, how you got into this job at Anthropic. Yeah, how did you end up in this role? It seems like you've done quite a range of different stuff in your career in the past.
Yeah, so I think most directly, a friend at Mila, which is another ML place, was talking with Andy over at Anthropic about some of the research they were doing. And Andy mentioned that they needed some infrastructure stuff. And I, at the time, was friends with this person. And they mentioned, well, you should talk to Nova. And so that's, I think, the main way that I got here. In general, my background is like pretty broad. I did information systems at UMBC. And so a lot of the work there was on the kind of corporate end and talking about like how do you do business information systems. But I think a lot of the best work that I did there was in the division of information technology. I used to work there, working on student systems and working on other systems there. And that's something that I kind of fell in love with. Before then, I also did a bunch of bioinformatics. And I think you can probably find some papers out there for me on orthologist genes and metagenomics, that sort of thing. And a lot of the reason that I got excited about that work was because there were like some very direct biological implications and really interesting things that came out of the computer work that I did there. And at the time, bioinformatics was sort of a nascent field in some ways. And there was actually work for somebody who was 12 working on that kind of thing.
You were 12 when you were doing that?
Yes, both my parents are microbiologists, and so I helped them out with their work quite a bit. Yeah, you can look up Halo Web sometime.
Nice. Okay, yeah. What were the biological implications of the work that you were doing?
So I did work on comparative genomics of Haloarchaea, which are these very salt-loving microbes that live in places like the Great Salt Lake and the Dead Sea and things like that. And they've got some pretty interesting gas vesicle nanoparticles, which is like sort of a fancy way of saying there's this protein structure inside of them that turns out to be very body neutral and immune system neutral and very easy to express antigens on. So there are some vaccine implications there.
Okay. When you say body neutral, you mean it doesn't affect the human body directly and it doesn't have proteins that tend to set off our immune system?
Yes. So if you think about, for example, like prosthetics or something like that, you oftentimes need to make them out of something like titanium because otherwise your body will interact with them in a way where there's like inflammation caused or something like that.
Yeah. Did you have a pre-existing interest in AI alignment and AI safety before getting involved in this? Or are you mostly working at Anthropic because you're interested in the like IT and computer security and like engineering aspects of the problem?
I've been interested in things that look like ML systems for kind of a long time. One of the most important techniques in determining what a gene does, what we used to do is something called like a hidden Markov model, which is like, I guess in some ways more primitive form of doing machine learning to determine the weights of a Markov chain. So that way you can figure out what protein function is from a gene. So that was something I used to have to do. And for a long time, I used to write, and actually still do write these chatbots for various kinds of systems, previously on IRC and now on Discord mostly. A lot of these systems interact with a lot of people. And you have to think very carefully about the UX of these sorts of things. So that way people sort of treat the bots well. There's sort of a humanization in some ways of trying to have the bot interact in a way that's personable. So that way people don't abuse the bot and things like that and are less likely to do damaging things to it. I run this project Fletcher, which does moderation for a large number of Discord servers. And in fact, this was one of the ways I got into ML. Is that I run these large-scale ML models doing inference on like a global network of computers for doing this. And that was one of the things that I was working on. I think Andy tends to appreciate that that's some deployment experience that I bring to the job today.
Yeah.
AI safety in specific, I used to read Less Wrong back in high school, and then I sort of dropped away from it for a while, and then I ended up back in the Bay, and people were talking about it, and it definitely seems like the sort of thing where it feels like infrastructure on the safety side is a limiting factor. And it felt like a place that I could sort of try and make there be a differential boost for safety researchers. And that's one of the reasons why I'm at Anthropic specifically, is because I think it's one of the places where infrastructure is the most important, and I think it's highest impact.
Yeah. Okay. I've got a lot of follow-up questions. So one project you've done over the years is use machine learning in order to train a moderation bot that monitors these chat channels and I guess blocks people and like deletes stuff based on its ability to infer that these are things that you don't want on the network. And you also tried to make it seem like a nice bot so people wouldn't try to attack it or make it not work.
Yeah, I think that's a good description. I think one of the roles, though, is it's less of it's going to delete things and more of it forms a model of what a conversation looks like when it is, angry or, heated or something that you don't want that's not on topic. And it's really quite a good use of ML, I think, in some ways, to try and identify those sorts of situations before they escalate and then escalate them to a human. Because oftentimes, like, these systems are not going to be reliable enough without a human in the loop, but they can watch everything when a human might not be able to. So a lot of the work with Fletcher is ping a moderator if something looks like it's about to get out of hand.
Yeah. Where do you get the training data for this? Is it just all of the past moderation decisions, basically?
So I can't talk about what the current model is because I open source it every time I have a better one to try and avoid people trying to do adversarial things with it. But the original model was a very naive sentiment-based model where it just looked for very high sentiment, oftentimes high negativity, looking for words where I had a very carefully curated list of things that should be brought to attention. And I was able to, crowdsource some of this information from moderators who already knew what they were looking for to convert these into these expert system rules. And then once I had that and I had some information about whether things did blow up or not, that was something that I was able to use to train models to identify these sorts of things, to build classifiers and that sort of thing. And I think my data pipeline is kind of interesting there, but I wish I could talk more about it.
Sure, yeah. Who asked you to do this, or did you just volunteer to do this?
So the original impetus for Fletcher was this. I was on a server that was run by a friend of mine who I had a crush on, and she was having some trouble with doing some moderation things and having some trouble with specifically moving things between channels. And I was like, well, this is a way that I can flirt with her. And she is now my fiance, and we work on a bunch of stuff together. And so I think it did work.
That is a fantastic way to woo someone.
Yeah, I tend to write software as that sort of thing. So
nice. So it sounds like you've been doing kind of interesting projects since you were a kid, basically. Are you one of these people who was doing really cool stuff at an age where I was like just completely wasting away my time?
I'm not sure that I would consider whatever you did wasting because you are here now, but certainly I wasn't this productive for this whole time. But yeah, I did a lot of science. I did a lot of computing stuff back in the day.
I guess that seems to be particularly common among tech people. I suppose just because the equipment isn't, one reason is the equipment's not so expensive and there's just interesting stuff that you can do that doesn't really require that much permission.
Yeah, I think tech in general has a lot of low-hanging fruit compared to, for example, say physics. Like there have been a lot of people working on physics for a long time and a lot of the easy problems have been solved. And so what you have left is these like quite hard problems that you might have to do a lot of thinking for stuff. Whereas I can mess around with a TI-84 Plus and get a lot of value out of that. I can do something that seems worthwhile. I could, for example, make a game, which is something that's like impressive to my friends, or I can make a computer algebra system, which is impressive to, my grades in the end. So I think there are very, very direct applications here. And it definitely appeals to the engineer in me more than the scientist, but I think that's okay.
Yeah. Did you have a particular kind of career philosophy that you've been following? Like, I'm going to try to get extremely good at some aptitude and then I'll be able to use it in future? Or have you more just been following your interests like year to year?
So I think my general guiding philosophy is to make choices that bring me more choices and to increase my capabilities, not on the AI side, but on the me side. So a lot of the work I do and a lot of the projects that I choose are ones where I think I'm going to come away with it better than I was before. So one of the things I admire is like the work that, for example, like a beginner blacksmith starts with very few things and makes like their first pair of tongs, right? and then you produce all these tools that you have built yourself that let you do really amazing things. And I think a lot of my career has basically been, I'm going to build a tool that lets me. Here's an example. So I like to read fan fiction. That's a thing that I enjoy. And so when I was choosing projects back in the day, I wrote a piece of software that interfaced like a fan fiction site with a computer readable protocol. And then I wrote another piece of software that took that protocol and converted it into a unified interface so I could have multiple backends and do the same thing. And then I wrote another piece of software that tied into that same thing that let me read those books in the browser. And so I've got this stack of like 4 pieces of things that all were individual projects that sort of tied into each other. And it meant that I could do a pretty impressive thing without that much difficulty. And having these tools has been basically, it served me quite well, I think.
Yeah. Yeah. Are there any other important decisions or strategies that you've made in the past or like used in the past that you think have helped to lead you to a good situation today?
Take opportunities. Basically, I think I tend to be extremely busy, and I think that I probably still lean on the side of taking too many opportunities, but it is far better to do that than it is to let things pass you by. You've only got a limited amount of time, and it's better to get into the habit of just sort of grabbing something. Even if you think that you might not be that good at it, you can always ask for help. And like being humble and asking for help and being willing to step up when nobody else will, or even if they will, still stepping up is, I think, really, really important for anybody, pretty much anywhere in their career.
Yeah. Is there any limiting principle to that? Are there any things that you've taken on that you kind of wish in retrospect you hadn't?
I think that certainly I've had projects that have, in the end, become, too big for me or have become something that's caused me some sort of grief. But I don't think that I really regret any of it. I think that I've learned things from all of those. And as long as I have, an exit strategy or, a next thing to go to, it's been pretty good.
Yeah. So you studied information systems, university.
Mm-hmm.
Maybe could you explain what's the difference?
Also classics.
Also classic. Okay. Real Renaissance woman. Can you explain the difference between information systems and I guess information security and computer security and I guess systems engineering? All of these things slightly blur together for me.
Oh, yeah. I mean, I think a lot of these terms are pretty much what you make of them. But if you're thinking about information systems in general, you're talking about not only the computer side of things, but also the humans and the data that goes into the systems and out of the systems and the business processes that surround them. So information systems is sort of the study of that. Computer security is more talking about the boundary, right? As you're talking about the boundary between computer systems. And then information security would be the boundary between human systems, human plus computer systems and other human plus computer systems. And then systems architecture, which is sort of a title that is pretty broad in some senses, is talking about designing those systems. If you think about what an architect does for a building, I like to make the claim that a systems architect does a similar thing, but without an architecture degree. So we make more mistakes. Yeah, that's basically what I do at my job, is trying to design these really complicated systems in ways that they will be maintainable and secure and reliable and efficient and all these sorts of things. So there's these properties of systems that I try and instill in them.
Yeah. How important was your undergrad in this whole picture?
I think that the experiences I had at UMBC were really quite exciting, and I think that I wouldn't be here if it wasn't for UMBC. But I think in terms of undergrad education, I think that degrees oftentimes don't prepare people too well for this sort of role. And
where's that?
I think a lot of the learning that you do is experiential, especially in computers. I think it's very much like an engineering kind of degree that gets taught more like a science. And I think some of my most valuable classes were the ones that sort of looked like, well, we're going to force you to do a group project with some arbitrary group of people on something. And I think that was really quite good. I think the information security program at UMBC is excellent.
And the stuff that's less useful, I guess, is the kind of the more theoretical computer science, which you don't get to apply as much?
No, I think the theoretical computer science is really important, but I think that as a new programmer, it's really hard to know when that's the right thing to apply. So here's an example. So I've got so say that I'm producing let's talk about Fletcher, actually, because I do this all the time. I could have decided that to write it efficiently, I would have to, write something in C, and it has a bunch of like very fancy algorithms to do something fast. But I didn't do that. It's in Python. And part of the reason that it's in Python is it is fast for me to iterate in that language. And it turns out that you can buy enough compute that it doesn't matter. Not like in a very broad sense. Like obviously if I was writing this in a much less, if I was writing it in TID4 plus basic, that would be maybe a bad idea. But for Python, it was the right choice because I could move fast. And it's really hard to get that intuition without doing stuff. Because like I have various functions to this bot that I absolutely know are O of n squared. So which is like saying that you've got a piece of the program that the time to run it increases as the square of the number of pieces of input. And I think a lot of beginning programmers will do things like, well, I'm going to do a bunch of work to like replace this with an algorithm that is O of n or is O of, square root of n or something like that. And like a really good programmer or somebody who's experienced will say, well, I can bound n. And that worst case is still fine, even if this algorithm itself is n squared. And those are the sorts of things that I think like theoretical computer science stuff sometimes falls down on compared to just make some stuff.
Yeah. So imagine there's quite a lot of people in the audience thinking, Nova seems pretty badass. I'd like to have that's a bit like Novus, or I don't know, I'd like to have a dash of this in my life. Yeah, is there any kind of advice that you haven't already given to people who are kind of interested in having a career that's a bit more like yours?
I think that computer science and technical stuff in general is most useful when it is applied to something that you already know about. So if you're somebody who's interested in, literature, but you also want to think about computer science, then find a journal that is interested in having a website and build them a website. Build them, a workflow tool. If you're interested in biology, do some bioinformatics. It's much more rewarding to do stuff when you can see the outcome and see the positive stuff that comes out of it. That's one thing. And the other thing is don't get discouraged too easily. And if you do get discouraged, talk to somebody about it. Because I wouldn't be where I am today without like mentorship and things like that, being willing to reach out to people to learn from their knowledge and that sort of thing. And I mean, send me an email if you're interested. So like I'm happy to connect people together, and you should be willing to talk to people. One of my favorite activities that I do, that I imagine that there are various government functionaries who don't appreciate it, but there's a thing called the Public Information Act or the Freedom of Information Act, depending on what level of the government you're at. And when I have a question about something that's running in an agency, I will just send in a request for this. And this turns out to be like a very rewarding thing because you will likely get an answer of some kind to this. It's a really big system, and it sometimes feels like you can't affect it, but it turns out that there are many ways that you can, and this is a very direct way of doing that.
Yeah, how much does it help to have a partner who sounds like they're kind of a fellow traveler, like have quite common interests?
It's fantastic working with Shauna. It's really nice. I think the one thing that I would caution against is if you're going to work with your partner, you gotta make sure that you've got good boundaries on what is work and what is not, because it's very easy when. So we both work at Anthropic and co-founded Hofvarpnir together, and I do Fletcher for things that she's moderated and that sort of thing. And, we do a Burning Man camp, and we do lots of stuff together, and it's very power couple, but I think being able to turn that off is really important.
Yeah, I guess it reduces the diversification that you have in life, right? Because your relationship and your work are like somewhat tied together. And so, yeah, I mean, some people recommend, get a partner who you definitely don't work with, who has kind of separate interests, maybe even, has a somewhat different personality than. Yeah,
I shouldn't date programmers, and honestly, that was what I started out with. But then she stopped doing physics and started doing programming, so I guess I messed up there.
right. I guess you converged a little bit over time. Yeah, I guess it sounds like it's maybe a slightly higher risk strategy, but one that is like very rewarding when it's working. And there's things that you can do to try to make it not as risky as it could be if you were not thinking about it.
Yeah, I wouldn't recommend going into a relationship expecting to do this sort of thing. But if you've got opportunities and it seems to work out and you're being gradual and you're being thoughtful about it, then yeah, I think it's pretty good.
What are the aspects of your current job that you most enjoy?
Well, one, they give me all the computers I can eat, which is pretty good. And so the scale of what we do at Anthropic is pretty exciting for me. But I think the thing that I most enjoy is being able to be around people who are smarter than me. I think a lot of the researchers have like very, very exciting things that they're working on and like deep understandings of ML systems that I don't oftentimes. I've got some basic understandings and I've got some principles that I work by, and I've done some deployment, but at the end of the day, I'm not driving the research forward. And being able to be in an organization that is advancing the state of the art and being able to be a part of that is, yeah, I can't recommend anything more. It's like being in the academy, but without as many of the granting politics.
Right. Yeah. Okay. So you said all of that positive stuff about Anthropic now. What are the parts of the job that you don't like that much, or at least that might not appeal to other people so much?
Well, two things. Parts that don't appeal to other people. For some reason, people don't really enjoy doing systems infrastructure, which is honestly their loss and my gain. But I think right now we're sort of people constrained in some of the tasks that we're working on. And so that can result in things being kind of tough for me to work on. So oftentimes the priorities there are quite a few of them. There are a lot of things that often feel like they're top priority. So that can be difficult. But I think that we've been working on it. We've got some new personnel coming on. I'm excited to, I guess by the time this airs, we'll have some additional infrastructure folks on. So I'm excited to have minions.
Yeah, nice. Let's push on from your career in general and talk a little bit about Anthropic and the work you're doing now specifically. So I've seen people have different views on kind of different safety agendas that different organizations have. There's Anthropic, there's the folks at DeepMind, there's the folks at Miri. I think there's Redwood Research. I don't know. There's a whole lot of organizations that are kind of started up, each with their own specific conception of what is going to, or at least what might help to make AI safer in future. Is there any way that people can go about kind of reading these different things or trying to form a judgment about which one they'd rather throw their efforts behind? Or is that maybe one where in your position you kind of have to defer to focus, just trust the judgment of people who seem like they're on the ball in general?
I think if you're interested in working in AI safety and trying to choose an organization, one thing you can look at is the output. You can look at what sorts of things they're releasing. If you're releasing more interpretability work, or if you're releasing more alignment work, or if you're releasing more capabilities work. I think that's in some ways the most important thing. You can also take a look at the output from people on podcasts and things like that. For example, I think Dario and Daniela at Anthropic were recently on the FLI podcast talking about what our theory of change is and things like that. That's a good way to get an insight into these sorts of things. I don't think there's really a central, I don't think anyone's done a ranking or anything like that. The other thing that you should do is you should talk to people who work there. I think that oftentimes people are more approachable than you'd expect. Naively, I think people are very busy, but it's often a pleasure to talk with somebody who's bright and is excited about the future or maybe concerned about the future and would like to do something to improve it, because not everybody's doing that. So yeah, I would say try and talk to some people.
Yeah, what are the opportunities to talk to people working at a place like Anthropic? Are there conferences or specific meet and greets for career purposes?
I think that conferences, certainly things like EA Global and ICML and there are lots of things where there are conferences. I'd say that if you see somebody doing work that looks interesting to you and you've read their papers and you have some questions about it, then you should email them. I think that the worst they can do is ignore it. I don't think that anyone's going to hold it against you to send a couple of questions or to ask for a few minutes of time. They might say no. They might say that, come back after you've done X, Y, and Z. There are definitely lists out there and things like that of ways that you can prepare and ways that you can make the most of time like that. But like I said, try and take those opportunities where they are.
Yeah. We talked about that issue of cold emailing people whose work you're excited by in the interview with Chris Olah. People can go back and listen to that interview from last year. Of course, Chris Olah, also one of your colleagues at Anthropic, so he knows what he's talking about.
Absolutely a pleasure to work with. So.
Someone in the audience wrote in with this question. Well, firstly, how did you get so good at DevOps, which I suppose we've somewhat covered already. But then they wanted to know kind of what advice would you have for people who recently graduated from a computer science undergrad degree, but they don't feel particularly exceptional at DevOps, but nonetheless, they'd like to end up in a kind of role like the one you have. It sounds like this person is asking for a friend.
Well, certainly they should email me, but I, of course, have to make the pitch for Hofvarpnir is hiring junior DevOps engineers, because I think it's really, really important to get more infra-y people in AI safety, and I'm willing to put in the mentorship hours to do that. But it turns out that it's easier than you'd think to try out some of the things involved in DevOps. Many cloud platforms have free credits especially for university students, but in general, they'll give you, $200 to play with, which is enough that you can run some pretty interesting things for a pretty long time. So I would recommend making an account at AWS and trying out some of the articles that they have. So they've got like things talking about like their Elastic Kubernetes service or something like that, or training a model, that kind of thing. I think that those the model thing is, I guess, more in the researcher end, but for DevOps stuff, try doing something like that. There are oftentimes opportunities that you can see in your life to build services that would improve something. The best thing that you can do, in my opinion, for DevOps is to build a service and then release it widely. Release it on Reddit, release it on, Product Hunt, Hacker News, that sort of thing. There is nothing like doing a launch. There's a joke about a QA tester walks into a bar and they order one beer, they order two beers, they order -1 beer, they order not a number beer, and then the first customer walks into the bar and asks where the bathroom is, the bartender explodes. And so that's just sort of, I think, a good representation of what it's like to launch. You see all sorts of very, very odd things that you didn't expect were possible, and it really helps you sort of broaden your worldview in terms of the sorts of things that people will do with systems. And that's the best thing to learn as a DevOps person. And yeah, email me. Happy to chat.
We've talked quite a lot about kind of self-directed and organic ways of building skills. Are there any kind of more formal courses of training that people could use in order to build their skills, or is that maybe the wrong way to be thinking about it?
I think that those courses can be useful. If you're on the website of things, MDN, which is the Mozilla Developer Network, has some interesting stuff. I think that there's some Coursera courses out there that have looked pretty interesting, mostly on the ML side and less on the DevOps side. The best thing that you could do, if you're in a university kind of role, you're in a good position to apply to one of these roles at a software company. Two things to keep in mind there. One, infrastructure is super in demand, it turns out. I'm not sure why everyone isn't doing it, because it's the most exciting thing in the world and possibly the best thing that you could be doing. But that's in your advantage if you're interested in this sort of thing. I think there are fewer people that you're competing with compared to a generic software position. The one choice you might want to make is between something like Google, Facebook, Amazon, those sorts of large companies where your DevOps looks pretty different from doing something at, for example, a startup, where the work that you would be doing is very much greenfield work, very much working with tools in a more direct way. You'll get more mentorship at a place like Google, but you might learn slightly different things, and you might need to do more projects on your own to see if you can apply those tools. Because, for example, if you work at Google, a lot of the really hard problems have been solved for you. There's a lot of people working there, and there's a lot of tooling that's been developed to make it so when a software engineer wants to launch a product, they have a very specific thing they can do. Whereas if you work at, I did a bunch of startups. I've worked at a bunch of Y Combinator places, and every single one of them has been, from the ground up. You've got to, look at the problems and draw out a thing on paper and then, make that happen. And you can choose basically whatever tools you want. And it's just a very different experience, I think. But yeah, internships are a good place for this if you're so inclined. I do still recommend doing your own projects, though, because I think there's nothing like that. If you're looking for more feedback, then that's where you want to launch, right? If you want to be able to, if you produce something that has users, those users will want things from you. And I think there's nothing like that.
Yeah. So let's talk now about kind of all of the different roles that Anthropic is trying to fill. It sounds like there could be quite a lot of different positions. Maybe it's worth going through them a little bit systematically. So what are kind of the different categories of role that someone in the audience could hypothetically apply for?
Sure, yeah. So I think that the main roles that we're looking for right now are things on the data engineering side, on the infrastructure side, which I'm leading up, and on the security engineer side, which is very, very related. I think the infrastructure and security run hand in hand. You can't do systems without thinking about security. But yeah, those I think are the main ones.
Okay, yeah, maybe let's go through those one by one. I guess not in enormous detail because people can obviously go on their website and learn more about them. But yeah, maybe what sorts of skills or background do those call for?
Yeah, so on the data engineering side, I think that we're looking for folks who are interested in taking a large pile of pretty unstructured data and structuring it and cleaning it and that sort of thing. You'd probably be familiar with tools like Spark or Hadoop, but honestly, if you know how to do sed really well, then that's also very useful. And so yeah, on the engineering side, that's pretty important. On the infrastructure side, I think candidates who would work well are people who, I mean, generally strong software engineers, but it's pretty easy, I think, to pivot from software into infrastructure if you're so inclined. But on the infrastructure side of things, if you've had experience with, for example, Kubernetes, that's a big boon. It's like quite difficult to replicate that experience. And yeah, so I think that's pretty important. Having worked with GPUs before, that kind of thing, because they're finicky beasts, unfortunately.
Yeah.
On the security side, if you've worked with a large system before, I think that's pretty important. But in a lot of ways, there's a lot of low-hanging fruit for systematizing stuff. So security engineers would be, there are a lot of very broad backgrounds that you could have that would be applicable to that.
Yeah.
Mostly you need to come at it with a creative mindset. More than anything else.
Yeah, that's what everyone always says about the computer security stuff. I think Bruce Schneier was like really on this line as well. Or basically, it's like you have to be the kind of person who looks at anything and is like, I could break, like, here's the weakness, here's how I would break into that.
Yeah. I think that Bruce is spot on with that. I think that's the most important thing in a security person is being able to think outside of the box. Because we talk a lot in security about something called fence post security, where you're walking in a desert and you see this like really tall fence post in the middle of the desert and you're just going to walk around that. The security is about walking around those fence posts that people put up. And so a good security engineer is trying to actually build a fence.
It kind of gesturing towards the idea that you can have this tokenistic security or tokenistic barriers, but then if they don't actually stop someone who's interested in getting past, then it might not be immediately obvious that that's the case.
Yeah, because I think it's very easy to get the blinders on and think a lot about, like, for example, like SOC 2 compliance or something like that. There are lots of like compliance procedures where simply doing the steps is not enough for your system to be secure.
Yeah.
And you have to be thinking about an adversary who doesn't care about those steps.
The rules, yeah. They
care about getting in. So...
Yeah. It's extraordinary how uncommon that mindset is. I think I may even have given this rant with Bruce years ago, but my bank literally calls you up on your mobile phone and tries to have secure conversations with you about your bank account without doing anything to authenticate that they are from the bank. And
have you considered changing banks?
Okay, well, I mean, I actually have. Yeah, I maybe seriously should do that. But then if you try to be like, well, I don't even know that you're from my bank. Like, why would you expect me to talk with you about this? They get kind of belligerent or like baffled by the fact that I'm not willing to talk to a random stranger, even though like it's extremely common to have people call you up and pretend to be from a bank. Yeah. Anyway, I don't know what there's to say about that, but that's kind of the state of like financial infrastructure.
I think that encouraging people to think about ways that systems fall down is extremely valuable. And in general, I think that even if you're not interested in doing security, you should still be thinking about these things, because in some ways, security isn't just about offense, defense. It's a mindset that lets you solve problems in out-of-the-box ways. I used to joke that anytime I found a security vulnerability in the system, it was, an unexpected patching mechanism. It's a way that you can update that software without having to go through the standard procedures for it.
Yeah.
So in some ways, a lot of security looks like this. Or like if you're interacting with a government bureaucracy and you're having a lot of trouble with like the standard way of doing it, that maybe you should call a senator. Who knows? That might be able to help. And that's like something that they won't tell you to do that on the website. You need to be thinking about all the ways that you can hit that problem. So
yeah. I read like a couple of weeks ago about these folks who's managed to steal hundreds of millions of dollars of some cryptocurrency, I think ETH, and basically they were like looking at various patches that had gone through to these interfaces that moved crypto assets between different blockchains. And they noticed that someone had accidentally programmed this check system that rather than check that it said that it was accurate, they instead checked that X and Y were the same. And so they could make the checksum be inaccurate, but then say that it's inaccurate. And it would say, well, these two match because they're both inaccurate. And so and then it would approve it. I guess it's the kind of thing that it's just so easy to look over when you're looking at the code. You're like, oh, it says like equals when it should actually say, I don't know what the like, it should be positive side is, but it seems like a kind of classic computer security error. In this case, costs hundreds of millions of ETH.
Yeah, so I've definitely seen that one going around. It turns out that the actual thing that happened there is It's almost funnier.
Okay.
Maybe not funny. I think it caused a lot of economic damage. But the thing that happened there wasn't that they specified the wrong check exactly. So what happened was, okay, so basically, when you think about something like a data store that is, I mean, say it's a blockchain, you've got inputs coming from somewhere, and then you store those output results on the chain in some way, or in this ledger. The way that ETH works is that, or Ethereum works, is that oftentimes the functions that are called on that blockchain store their results in the blockchain. And you might have multiple functions that need to be called to verify the same thing. And because it's quite difficult to modify protocols after they were created, the Ethereum developers put in a bunch of functionality to modularize things like checks. So for example, if you wanted to upgrade the security, you needed to like increase the number of bits in an encryption key or something like that. There are ways to do that without having to have everybody update their software, which would be impossible with a distributed system. So what they did, the attackers did, is that there is a thing on that chain that verifies whether the protocol that you are asking it to verify your signature with, so the verify verifier, is a system output. But if you store something to the chain fast enough, you can say that check returned true even if that function hasn't finished. And so they were able to inject this bad check, the one that it is accurate the way you're talking about that. But the way that they were able to do this involved basically a race condition between two systems trying to verify
Put their thing
this
on the chain.
Yeah, exactly. So I think that's...
So it's slightly more complicated.
Maybe, yeah. It's slightly more complicated, and it required a little bit more thinking outside the box than noticing this one vulnerability. But it is still, it's a great example of like how a computer security error can have a very large economic impact.
Yeah. I guess to come back to what we were talking about, I was just thinking of this as an example of like someone who has this mindset of just like, I'm going to break stuff, might like look at that code and be like, wait, couldn't you race to like put in this like alternative thing on the chain? And
exactly.
If you got it in first, and if you're the kind of person who weaknesses like that jumps out at you, that you should go into computer security.
Absolutely. Yeah. I mean, I think that there are many things that you can do other than computer security, but computer security is full of these sorts of things, and the rewards for finding it are, I think, much higher than in a lot of other places.
Yeah. Are there any sorts of people who think they're kind of not qualified or not suitable to work at Anthropic or in these kinds of roles, but actually are? Is that a phenomenon?
Yeah, I think we see that sometimes. I think the things that we're looking for are folks who are relatively self-directed and are able to pick things up fast. I think the biggest thing is like you might not have a huge ML background, but if you're a really strong software engineer, like I was saying at the beginning, I think sometimes the ML is pretty easy compared to the software engineering problems, and you can pick up the ML. Jared Kaplan has a really good note that he has out that's, I think, really targeted at physicists about learning ML, but I think it's one of the clearest things out there on this. And so I think like if you think that that's readable and you're otherwise a pretty strong software engineer, then I encourage you to apply.
Let's just talk a little bit about what people in the audience can potentially do to tighten up their personal computer and information security, and I suppose like what stuff they might be able to introduce into their organizations in order to be able to lift their game. We'll be able to link to a doc that I think you've been involved in writing, I think called Security Recommendations for New Orgs, which covers some of this. Yeah, maybe let's try to keep it to 3 like top recommendations. What would number 1 be?
For an organization or a person?
For a person.
For a person. Number 1 is, I would say, use 2-factor authentication everywhere you can. It doesn't matter if your password gets compromised, if you are able to deny access anyways, because they don't have a hardware key. I think on that same front, use a password manager. Yeah. Please use a password manager. You are decreasing the blast radius of any given compromised password by doing this. So do that.
And that's because if you use the similar passwords or the same passwords in lots of different places, then if someone steals one, then they've stolen all of them.
Exactly. Yes. And that being said, even if you make no other changes and you don't actually use a password manager, certainly have your mail password be
different, because that's the skeleton key to everything.
That is a skeleton key for resetting so many things. Very frustrating sometimes. And I think that, like, I guess if we had to pick a third thing, I mentioned use an ad blocker. I'm going to say it again. I think that using an ad blocker is really, really, really important here in preventing random malicious code from being injected in your computer.
Huh.
So
I didn't realize that ad networks had become such a common source of malicious code. It's kind of surprising they can't tighten themselves up.
I think that the incentives really aren't in place for that.
Right.
Because it's not like the ad network is going to stop being used if there is any malware delivered by it, because it's really hard to trace it back and things like that. I just think that the incentives just aren't in place for this. It's less bad than it used to be. I think in the bad old days, you could, throw any JavaScript you wanted in there. And then we changed doing that because it was bad. But that being said, I think it just still is
There's such a juicy
quite
target.
unfortunate. Yeah. I mean, because if you, for example, if you're sending something and you want to target a specific person, you can do all these targeting mechanisms that you wouldn't otherwise be able to do by saying like, well, I know that they, work in San Francisco and they are probably using a Mac and like da-da-da-da-da. So it's worth doing.
Yeah. I suppose most people, I imagine everyone listening to this show is going to be familiar with two-factor authentication, where you get that 6-digit code that you take out of your phone or from SMS and plug it in. The thing that ideally we would be switching over to for almost everything is one of these hardware keys, which is, a thing that you plug into your computer and you press a little button on it and it does a cryptographic operation to prove that you have had that key on you. I think there's a bunch of different ways that that's a whole lot better, but one of them is that it's a lot less vulnerable to phishing attacks, so effectively, even if you have two-factor authentication where you're getting that 6-digit number, if someone sends you an email and directs you to a fake login website, they can just immediately take both the password that you've put in and the 6-digit that you've put in, the second factor that you put in, and just like log in as if they were you somewhere else. And that is, I think, like quite a common way to break into people's accounts. But that is basically not possible with these U2F hardware keys that have become reasonably common. And you can now like lock up your Google account and your Facebook account and many other accounts with those.
Mm-hmm. Yeah, and I really, really recommend those. I also recommend getting 2 keys because I think one of the concerns people often have is that they might lose this key. And that's a reasonable concern. So you should have 2 of them. Almost any reputable site will let you register multiple keys for something like this. Keep one of them in a secure location and keep the other one on your keychain, and you'll do a lot better. I also didn't mention, if you're buying technology, try and ensure that you're buying it from a vendor who is reputable. It's very easy to buy things like USB cables and stuff like that from, whoever the lowest dollar amount on Amazon is. Keep in mind that if you're plugging something into your computer, you are giving whoever produced the device hardware access to it. Even something like a USB cable can be pretty trivially compromised. You have no way of looking inside that cable really and checking if there's a chip there that, when your computer's away will turn into a keyboard to start typing some stuff there or something like that. And that's not a theoretical attack. We absolutely see these in the wild. So I guess that's the other thing, which I guess you asked for 3 and I gave you 4. So sorry about that.
No, that's totally fine. Yeah, so where should I go to buy hardware like a USB hub? I mean, I've bought those things on Amazon before. Is that a problem?
I think there are some concerns with Amazon in terms of mixed inventory and things like that. I think that if you can buy them directly from vendors, this can be better.
Okay.
That's one thing. Oftentimes, I mean, I live in the US and I have some amount of extra trust there for US companies and trying to get hardware that was at least designed in the US. This isn't necessarily something that will always help you, but it's at least something that can help as a heuristic.
Yeah. I suppose, what about going into a shop, like going into a computer hardware shop? That's probably better than Amazon?
It might be better than Amazon in some ways, yeah.
Okay.
Because I think that their supply chain looks kind of different.
Yeah, that makes sense.
Amazon does things like mingling their inventory. So they might have a device that they bought from several different people in the same bin, and you have no way of really knowing whether the thing that you got was from the original vendor. Or, I mean, worse if it's somebody swapped something out in the box or something like that.
Yeah. I guess you've spoken positively about MacBooks. I guess, in general, do you think MacBooks are a good laptop from a security point of view?
I think they are. I think that Mac makes it very easy to always have encryption on your hard drive. File vault, you should always enable that.
Yeah.
And I think that their encryption hardware is pretty good. They have some good incentives in place to ensure privacy and things like that. So I sort of trust that they're making a good effort at it.
Is iPhone still substantially better than Android phones, even like the Google sold ones?
I would say that that's probably true, but in general, I mean, I use a Pixel, and my general philosophy here is that if you are accessing something or if it is accessible from your phone, then you should treat it as compromised. And
I see.
Yeah.
So phones are just like sufficiently insecure in general that you don't want to be doing anything sensitive on them ideally.
Yeah. I mean, I think that there are some things that you can do. I think Android is at all secure, especially with things like a work profile. You can set apps that are for your work separate, basically on a separate partition.
I see.
From everything else. And I recommend doing that if you're going to use an Android phone, which I do.
Okay. Yeah, do you have a view on, I suppose obviously people should keep their operating system and their phone and their like browser up to date with all the necessary patches. Any preference on like browser choice or browser behavior beyond the having ad blocker?
So I use Firefox for my personal stuff. And the reason I do that is I think less on the security side and more on I think that there should be multiple browsers and that like the web should not be siloed into a single browser's thing. That being said, if you're going to choose one browser, you probably should choose Chrome. I think that Google has more folks working on it than Mozilla has on Firefox. So I think some of those security properties can be better, assuming that your threat actors don't include Google.
Okay, yeah. An important thing to add there. So for a number of years, I used LastPass, and I was incredibly irritated that despite the fact that these kind of U2F keys were becoming very common, widely available, like dramatically improved security by having this like multi-factor authentication, something that you definitely like have to have in your hand in order to be able to log in, that LastPass just did not implement this, despite the fact that their whole thing is to be the most secure thing because it's holding all of your most sensitive information. So anyway, I switched away from LastPass. Yeah, do you have any views on kind of what password manager people ought to use? And should I like be as disgusted with LastPass as I in fact am? I'm extra annoyed with them because they claimed for years that they were always about to implement it, and then they just like stopped even saying that.
Yeah, I think that that's definitely a strike against them because I think that two-factor authentication using hardware tokens is absolutely the way of the future. I expect that to broadly expand as we get easier libraries for people to implement and more demands on things like a SOC 2 audit for security that is more than just wallpaper. So I agree that that's definitely something that I would love to see out of LastPass in terms of expressing a better interest in securing your passwords better. I think a lot of folks use 1Password. 1Password's been pretty good on this front. That being said, the best password manager is the one that you use. So if you are a person who's thinking about getting a password manager, I highly recommend starting with something like the built-in Chrome one or the built-in Firefox one. It's pretty easy to migrate away from them, but you will use it. And that is the most important thing, is having separate passwords for every site is consistently always using something that contains a vulnerability that you might have on one site if one password gets leaked or broken.
Yeah. A vulnerability that I've always kind of worried about is that you're inserting passwords, including often your password to your main password manager, into a browser. And like all of the extensions that you have within that browser, I think can kind of see those passwords, or they can like see the keystrokes that you're entering into our website. And, you know, Chrome extensions, Firefox extensions have a record of being like regularly compromised or regularly like sold to bad actors who then, you know, use them potentially to steal passwords. There are a lot of these kind of just like gaping holes in the way that ordinary people use computers that are making them like much more vulnerable than they really ought to be.
Yeah, I think in security we talk about these as side channel attacks, where the primary channel would be, you know, breaking into your bank. And the side channel is you put a keylogger on somebody's desktop so you can grab their password instead. Certainly, extensions are a big concern here. I use quite a few extensions. I think that this is definitely a thing that's like quite useful. I am also in a role where I am being paid to be professionally paranoid, and so I read the code that's being added to those. Trying to limit the number of them that you're using, trying to keep an eye on what's happening there is important. I would say that browsers are more secure than I certainly thought they were back in the day. Chrome especially has had a lot of work done by a lot of people working full-time to sandbox execution of arbitrary code. So when you think about programs, right, oftentimes they are something that's written by somebody else that's running on your computer where your data is. And the web is increasingly like this. We're recording right now on Riverside FM. It's got video, it's got audio streaming, it's uploading files, it's downloading files, it's able to do all sorts of really, really exciting things. And this is inside the browser. And if it was something that you would ask me to download, I would have been a lot more concerned, because I think that the JavaScript sandboxing ecosystem has gotten very, very advanced. People have put a lot of thought into how to do smart things with it. So I think that browsers in particular are oftentimes more secure than things that you're running unaudited on your laptop. This is actually something where desktop operating systems have actually taken a page out of mobile's book, though. I think sandboxing by default is something that's true on many apps and things like that. Like permissions dialogues for requesting access to information were not a thing on desktops, really, because we didn't start out thinking about that. The permission scheme for files on a Linux or Unix operating system has a set of permissions for read, write, and execute for a user, group, and everybody. And for the longest time, everybody could access everything. This was like expected. You were inside of a university. Everybody was trusted. And moving to this model where things aren't trusted by default has been very painful, but that I think that browsers have been leading the way on that. So that's pretty exciting.
Okay, yes. So as far as I understand what you're saying, I guess in the bad old days, we had this issue that if you loaded up a website, like Internet Explorer or whatever browser you were using, was not sufficiently good at sandboxing, which I guess is kind of constraining the code that's running within that web page to just interact inside that web page inside the browser. Instead, they could frequently find ways to get their tentacles into other parts of the disk, other parts of to run code that you wouldn't expect them to be able to run. But these days, we've gotten better with Chrome and Firefox, and I guess like just better computer security in general, at figuring out how do we make sure that this tab that we're using right now to record this conversation can only do the things that we would expect it to be able to do inside this browser, and not to access files that it can't access, not to do like broader things on our MacBooks that are like beyond the permissions that Chrome has given this particular tab. Is that right?
Yeah, I think that's a really good gloss of this. We've developed a lot of tools recently. You were asking, I think, about whether things have gotten better or worse here. Our testing for security vulnerabilities has gotten unimaginably better over time. There are things like fuzzers. There's a thing called American Fuzzy Lup. Look it up. It's a piece of software that generates inputs to systems to try and cause undefined behavior and things like that. Being able to produce these like sort of weird automated test streams to break into things is like a new innovation, fuzzers in general. That being said, for browsers specifically, we used to have things like plugins, right? And so I think maybe it's not clear what the difference between a plugin and an extension is. So a plugin is oftentimes something that's developed in native code. So you've got something like the Java virtual machine, or the Java plugin. It's probably going to be written in C, and it's something that runs on your hard drive separate from the browser process. You've got Flash. Flash is oftentimes very controversial in terms of being very easy to use, a great creativity boon, and also the source of countless
ungodly numbers.
Oh, for sure. Yeah, it was quite bad. The death of it was very bittersweet, I think. But for example, like I've got an extension for making sure that things only run inside of the Facebook sandbox. And that's something where I can verify that it does what it says it does. I can rely on the JavaScript sandbox to restrict access to other sites and things like that.
Yeah. Okay, we've taken up a ton of your time, and as I'm sure people who have got the impression, I'm sure you have a ton of stuff on the go to immediately go work on. Maybe a final question: do you have a kind of favorite story of a hack or a computer security breach that would be fun to share with people?
Sure. Yeah, I think the one that springs to mind is Stuxnet, which you may be familiar with as a quite an interesting state actor hack. So basically, what happened in this was that, despite these centrifuges that were being used for enriching uranium being on a completely air-gapped network, and despite them, being in a secure facility with the guys with the guns outside, we managed to, the U.S., I think, national security apparatus managed to get a virus onto these systems that adjusted the RPM, essentially, of these centrifuges to get them to break themselves. And it's honestly, I think it's very hard for me to give a concise version of this thing, but it's definitely worth looking up. And I would also recommend the podcast, The Darknet Diaries, for this.
I started listening to Darknet Diaries. Oh, I think it's like opening line is, "These are stories from the dark side of the internet." And I was like,
I know, it's so dramatic.
I'm not sure that serious computer security people listen to this podcast, but maybe it sounds like actually they do.
They do, I think. It's certainly entertaining, and I think it's a good way to get ideas of like the sort of crazy things that people do to break into each other's stuff.
Yeah. I've been listening to that podcast recently, and I'm glad I shouldn't be too ashamed of the fact. On Stuxnet, there's this great book about it called Zero Day. Which it's a very fun potboiler that goes into all of the technical aspects of it, and which are truly remarkable. I don't know when we'll see the next most impressive technical hack from that point of view. I
have no idea. I'm very excited to see it.
Yeah, for sure. Well, my guest today has been Nova DasSarma. Thanks so much for coming on the 80,000 Hours podcast, Nova.
Thanks for having me.
Okay, so as promised in the intro, I'm now going to go through a bunch of other shows you might be interested to subscribe to if you like the 80,000 Hours podcast. Don't worry, we're not getting any ad or sponsorship revenue here. I'm just being a helpful person, and I'm a big personal fan of podcasts. Probably the single most similar show to this one anywhere is called Hear This Idea, and that one is hosted by Finn and Luca. Like all of the shows I'm about to mention, it's another deep, lengthy interview podcast, and the two hosts describe it as a podcast about ideas that matter, showcasing new thinking in philosophy, the social sciences, and effective altruism. A fun episode from them to check out first might be episode 34, Anders Sandberg on the Fermi Paradox, transhumanism, and so much more. A second one worth checking out is called Narratives, and that one is hosted by Will Jarvis. He describes his show as about the ways the world is better than in the past, the ways it is worse, and paths towards a better, more definite vision of the future. A top recent episode for me was number 90, titled The 800-Year Decline in Interest Rates with Paul Schmelzing. This third one, many of you will have already heard about, and it's called the Future of Life Institute podcast. That one is focused on existential and catastrophic risks and how to prevent them, as well as long-termist issues more broadly. While the topics are similar to this show, I'd say the FLI podcast is a notch more serious and a notch more technical than we are. If you look back into their extensive archives, you'll find a long series of episodes on AI alignment research and another on climate change, which in aggregate would take you very deep into those respective topics. A reasonable place to start if you want to check out the FLI podcast is just their most recent episode, Daniela and Dario Amodei on the AI company Anthropic. Fourth, we've got a hugely popular show that has now been running for an incredible 12 years, and that's Rationally Speaking with Julia Galef. Julia is open to covering a wide range of topics because her main goal is to showcase reasonable and even-handed, thoughtful conversations about difficult and sometimes divisive issues. A fairly recent episode that was very memorable for me was number 250, a conversation with Julian Sanchez on what's wrong with tech companies banning people. Fifth, we've got a show along similar lines called Clearer Thinking with Spencer Greenberg. Spencer pitches that show as a podcast about ideas that truly matter, featuring fun, in-depth conversations with brilliant people. Spencer is pretty eclectic and has very broad interests, so he talks to all sorts of folks, including some I think have great ideas and others that I think are pretty misguided. But he always gives his guests plenty of room to lay out the case for their personal and unique perspective on things. A memorable recent conversation for me on that show was episode 97, Why is Self-Compassion So Hard, with Kristen Neff. A final one that almost none of you will have heard of is called Un Equilibrio Inadecuado, or in English, Inadequate Equilibria. It's basically an attempt to do this show, but in Spanish with Spanish-speaking guests, who I know we have quite a lot of in the audience. I can speak Spanish reasonably well, and I still had to slow it down a fair bit to follow, down to maybe 0.9 or 0.8x. But it was a great way for me to learn vocabulary that's really relevant to the topics we talk about on this program. A good one to check out first on there would be Julio Elias hablando del tema de mercados repugnantes. Currently, the show isn't getting new episodes, but hopefully its creator, Fernando Folgueiro, or someone else in the Spanish effective altruism community will be able to pick it up and do more interviews in future. I just mentioned a lot of shows and episodes there, but if it's easier, you can head to the transcript for this conversation on our website, scroll to the bottom, and find this section, which will have links to all of them so you can go through systematically. All right, the 80,000 Hours podcast is produced and edited by Kieran Harris. Audio mastering and technical editing for this episode by Ben Cordell and Beppe Rodvik. Full transcripts and an extensive collection of links to learn more are available on our site and put together by Katie Moore. Thanks for joining. Talk to you again soon.